Second try here. Let me just wait a little bit, see if it starts on the... Okay, finally. Yeah, I don't know what's going on. I think for YouTube you have to start on the site first, and then you start on OBS. In Twitch, I usually start from OBS. Actually, I always start from the OBS. I don't even know how to start on Twitch itself. But in YouTube, like, looks like it's different, but it looks like now it's working. But yeah, as I was saying, I'm gonna work on the poker stuff now, because on the project that I'm working on, I'm gathering data and cleaning data, and it's taking a long time. And I also feel very motivated now to do the poker stuff, because I think it's gonna it's something that I'm actively doing and I'm curious about, and I think it's gonna be really interesting to see uh, what I can do with that. And I found this stuff. I was looking through this documentation of BioSolver, and they have an interface to communicate with BioSolver to build programs. And I didn't see this that they had this repo here. I forked the repo, and is an example of how to connect with the BioSolver with Python. And I didn't see that they have this last time I saw the documentation. And I took a look at this, and it doesn't seem complicated. And I also opened BioSolver with the logs that they recommend for you to see what's going on. And it looks like it might be difficult, but it looks like at least everything that I want to do is possible. Because you have these commands here. The minus is the command you're supposed to write, and then the plus is the output. So minus is input, plus is output. And then everything you do on the solver itself, it shows there. Maybe not this, but when you click build tree, then the commands show up here. So I think it's just as basic as understanding how to connect here, to translate this part into Rust, or maybe I'll do it in Python, depending on how hard it's gonna be. But then I can get the commands from this thing here. I can do the things that I want to do manually here. And after I connect, then all that I have to do is parse these into strings and use the system output and input. And I think it's probably pretty easy to do it with Rust as well. It should be a great learning experience. And then, yeah, it doesn't look like the most difficult part is gonna be thinking about the data analysis and formatting stuff, which is what I'm gonna do right now, and also studying polars to understand how it works better. Yeah, I'm gonna train touch typing now as well, because I feel like I was almost beating my record before I started streaming. So I still suck at touch typing, but the goal is to get you 200 words per minute eventually. I don't think it matters that much for coding, but I don't know. It's just I enjoy practicing it, and it's something that at least it helps a little bit, because it helps you write better. But it's not that is that much of it's not that big of a deal. And now, oh fuck, clicked the wrong thing. I was figuring out there was a mistake. If we're gonna use polars for in Rust, first I'm gonna explain what the confusion that I had there. But let me wait until I can open the file, because I clicked this accidentally. So I was getting an error on this file here. The thing that I didn't understand is the recommendation and on the documentation and the stuff that I saw from polars, they tell you to do it like this. And I didn't understand because I thought this was from the CSV library, but it's obviously not. It's from the polars prelude here. When you import with the star, you're importing everything that comes from polars inside of this module. and this module contains the CSV reader from polars. So here I'm actually not using the normal CSV reader, I'm already using the library, which makes sense. But I didn't understand that, I got confused there, because I thought, where is the polar supposed to come in on the thing? And yeah, now it makes a lot of sense. And the other thing that I was getting an error was I was using the result here to return, because that's what's recommended when you're gonna read files or call APIs or anything like that. The return type is usually the result, and then you have to handle the result, the error, by putting this question mark here after the methods. That it's kind of like wrapping code inside of a try catch block or something like that, or try except. But you just put the question mark here. And in this file, I was using like this because that's what I saw on other documentations. And then I was trying to do this on this file, but then it was giving me a mistake that I wasn't implementing a trait for an error. And the problem is that when you're using the polars library, it seems like there is a conflict between the error typing polars and the error typing in the standard library. And then I looked at the source code of the documentation, and the source code shows this type here, so I put this. Probably I'm gonna have some problems with this as well, so should be interesting. Let's see how I figure that out. And then here I was trying to build something really basic to read the file here. But then I realized that it's probably better to separate this file to create the bridge between the CSV and the MPIO, because I already have a script here to, not a script, but a file. I'm not sure how it's called on Rust. I guess I'll just call it script, whatever. So I built this thing to print the file. So I thought that it makes a lot more sense to do the parsing of the file in this that I already have the code. And then after I parse the file and save in a CSV format, then I'll start working on this one. And the reason why I was thinking about doing here is because of this H5. I remember when I stopped this last time, I don't understand how the H5 works, H5 format works very well. But I think that I have to structure the file as a CSV either way, regardless of how it is here. So I think what I'm gonna do is, I already copied some of this, but I wanna read the format here that I'm getting, and then I wanna write what kind of patterns I'm gonna filter this file from, and then I'm gonna search for how to create different colors, and then I'm gonna write to a file in CSV format, but I'm gonna try to write it into H5. So I'm gonna structure in the same way that I would structure a CSV, but I'm gonna write it to a H5 format because I think it's faster. And hopefully it works. And then once I have that file with the columns and the patterns, then I'm gonna come over to this file and then read that file. And then from that file, I'm gonna see this stuff here that they made in Python, and I'm gonna try to translate this code into Rust to connect the file solver with my Rust code. And the thing that is gonna be the hardest for me here is that I'm gonna have to translate these functions into classes, these classes and functions into structs and traits and implementations, which I don't have experience at all doing. And I don't know how to think about it really well, because I'm new to Rust and these concepts, so it should be interesting as well. Oh, they are from this part here. The main file has a class, I think. Yeah, class solver. And then after that, then I can start thinking about how I'm gonna build the simulations, which I think I'm gonna open Pile and then copy the commands. I'm gonna do everything manually and copy everything. copy all the outputs from the pile. So let me think about this format here. So the session I think is irrelevant because I don't really care about what session each thing was. I care more, obviously, more about the overall hands across all of the data set. So I don't think it matters. The round, I think it matters. That's the thing. But I think this, I'm gonna filter by type because it's a lot better. Maybe I should, oops. I think I'm gonna write it at the end here, after all of this. I'm probably gonna erase this. I'm just put it here in case I lose the output here, so I don't have to run it again. And so I have an idea of how the format works of the file. So cards type equals river. And I'm gonna have to check or to search for how to filter this as I parse the file, which I think is gonna be kind of hard because of the types and stuff like that, which is weird to me. Not weird, I'm not familiar with working like that. I'm more familiar with the way that Python works. So obviously I'm gonna need this cards type here. It's gonna be river, probably river turn and flop, obviously. Yeah, there's turn there. The other thing that I'm not sure is I would I'm only gonna resort to regex at the as a last resort kind of thing because I hate coding regex. I think it's really annoying and I suck at it. So hopefully I can use a string slice to filter. Yeah, so the way that I'm thinking right now is I'm gonna figure out a way to loop through the string instead of doing like this, which I'm not sure if it's possible or not. I think this is similar to the concept of Node.js, where you create a string of reading, where it doesn't read the whole file, it's kind of like an iterator where it generates the string as it reads. As far as I'm thinking about it right now. I might be wrong, but that's how I'm thinking about it. And then this method from the buffer is the thing that creates the string, which in Node.js I think would be read string, the method, but I think it's the same concept. So the problem here is that I have to figure out how to use the buffer reader to create an iterator, and then through the iterator I create a pattern, and then I can create a match through the pattern. And then through the match, I separate the vectors. So maybe I should write this down. Iterate. I think I'm gonna do like this because it's gonna be multiple steps. Iterate over a buffer. Oh, actually, create vectors for each column of pattern. Iterate over buffer. Create match for each pattern and appends to the vectors. Right, CSV. Oh, I should probably train PyCharm as well today because I haven't been training at all actually, because I'm so busy with the other stuff that I'm doing, the other projects that I'm working on. And it's kind of hard to train PyCharm because I'm not really our VS Code key shorts because our key shorts shortcuts because I don't really see the Vim. I was a lot more invested on because it was something that I was curious about and I wanted to learn. But PyCharm and VS Code is harder to see the benefits because I'm not as invested into understanding. So it's kind of hard to get myself to train as well. So I think I'm gonna train for a couple of hours maybe in one day instead of training each every single day for in the same way that I trained Ving, because that way then I can get over both of them fast, go through all the levels, and then do over and over again. And I think at some point in the future, maybe a couple of months from now, or maybe 1 year from now, once I have done all the stuff that I'm thinking about doing now and that I have to do, then I'll come back and then I can train the shortcuts again. So I'm thinking that's probably the best way to go about it. Oh, the other thing that I forgot to mention is that I found this stuff, looks like it's new. There was a guy that went through free code camp, and then he apparently ended up making millions of dollars by building a company on Web3. And then he donated 1 million to free code camp for them to do this stuff here, which I thought was really, really cool. And I think I'm gonna try to do this build a peer-to-peer network, which is the one that I'm the most interested on about Web3, because I want to understand how the nodes connect with each other and how the mempool is connected in Web3 in order to understand the builder proposer separation and how this dynamic of block builders work on the blockchain, because I think that's the way that's the most interesting thing about blockchains in my mind right now. Because the way that I see it is like a movement, like in anything else. You have a pendulum going from left to right, right? And obviously, is always relative to the experience of the observer because it's a multifractal pattern that is a bunch of polarities, relative polarities, creating this geometrical configuration, which is space-time, in relationship to the identity that is perceiving itself through the lens of infinity over the computation of an awareness. And the blockchains are the decentralizing force, or the decentralizing force in the beginning against the current system. But the thing is that they are embedded in the economic system, so they can't overcome that in my mind. So it's an attempt to decentralize everything, but obviously it's going to fluctuate through centralization again, which is the forces of the market economy, because it's going to follow the Pareto distribution. And then now that this force is being exercised, there's going to be a movement. It's already happening, this movement towards decentralization again. So it started off as fully centralized in Bitcoin, and then with Ethereum, it started moving more and more towards centralization because of the MEV. And the way that MEV works is that people are incentivized to build blocks in a way that makes them money. So the miner had the power to create a block, which gives them more money, which is centralizes everything because of the force of the dynamics of markets. It creates a Pareto distribution and then generates gravitational force because the person or the miner that is getting the most rewards reinvests the money, and then there's an asymmetry of information and power. And over time, it fluctuates through an exponential distribution. And then in order to combat that, what they did was the proposer of builder, validator, separator, which is separating the role of the validator and the block builder, so that this force of the centralized force is mitigated. And I think that's really interesting, because I think that's the flow of one side to the other is the attempt to find the equilibrium in a market economy in a programmatic way, which I think is the path to try to contain the force of exponential attack in a way that balances everything out so that we don't kill ourselves. So that's why I'm really interested on this, and also because I can make money by understanding this dynamic as well, because I think there's a lot of opportunities. And then the other thing that is interesting is that there's also this thing that is happening, which is the rollups in Ethereum, which are pretty much another centralizing force because it takes the computation off chain so that Ethereum is more scalable, but the trade-off is that the sequencer, which is the person or the entity that has control over the validation, the bridge between all the transactions and the layer one, has the power to censor transactions and it becomes more centralized, even though it is decentralized because of the layer one thing, but it's more centralized than the full layer one would be, if that makes sense. So I think the question here and the quest is to understand or think about what would be the optimal way to scale without losing too much of the decentralization, because the best solution is going to be anywhere between the fully centralized and fully decentralized. And what's going to matter is the frequency of change between decentralization and centralization in relationship to the technology. And I think the key pillars are probably cryptography and the structure of the network, of the game theory between the validator and the builders, and understanding the data that creates the game theory. And I don't understand, I lack a lot of knowledge in the network. That's the part that I still, it's kind of a mystery to me still. The other stuff, it's still a little bit complicated, but after studying a lot, I think I understand now a lot better of how the VM works and the lower level structure. But the network I haven't have practice yet. And I think a couple of weeks from now, or it's supposed to arrive here at the 25. Bought more hardware, and once the hardware comes here, hopefully, if everything goes well, I'm gonna run my own full archive node, and obviously, once the time comes, it's better to understand how this works, because then I'm gonna be more prepared to build a node and to actually extract information from it. But having said all that, I'm not sure if I'm gonna do this because I don't know if I have enough time. It's gonna depend on the stuff that I'm doing on other projects as well. Yeah, I think I'm gonna put some music and then I'm gonna try touch typing before I start to work on this. But let me see here. Create vectors for each column of pattern, iterator of a buffer, create match for each pattern, and append to the vectors, write CSV. Yeah, then once I have the CSV, then I think is the other file. So I have to think about what patterns. Maybe I'll write this stuff first and then I'll train touch typing and then come back to this. Yeah, one thing that would be helpful is to know how to copy a line. I think it's Control D actually. Yeah, Control D. Nice. Okay, so I think for the player, I'm gonna let me put abstract streets. For the player, I'm gonna use just the P6 or P5, obviously. I'm not gonna use this number because it's anonymous. I'm playing on Bulldog, which is the same site as Bovada. This actual number I also don't understand if it's anything useful. And then this I also don't understand. But I think the sum is probably the amount of money on the pot, maybe. Hmm. So the text inside of the yeah, this is gonna be a little bit hard, I think, because gonna have to think about. Oh, maybe I can. Yeah, I'm probably gonna have to use regex. I don't think there's gonna be a way out because I'm gonna have to specify. This also seems like it's something very similar to what compilers do, probably. So it might be worth to study compilers, which is also something that I'm interested on. I read a couple of articles about compilers and were simple compilers and they were written on C++. And I thought it was really interesting. I think what is one of the main fundamentals and first principles of learning how to code, and I think it's really important to understand. So I'm probably gonna study that as well. But I wanna study in a language that I'm familiar with, so I understand the principles and I'm not lost on the syntax. I don't know what C3 means. Oh, it's probably club of trees. So clubs is probably C, if I had to guess. Yeah, S is spades. Where did I? Okay, the sum is here. Ah, so interesting. So I'm gonna put this example here, H2DACK, because it shows that when there are more cards, that's how the format's gonna be. Yeah, so I'm pretty sure that this is the format. So what's the name of this? I guess I can call symbol is first, cards, value comes after. Yeah, the other thing that I'm gonna have to do is create the heuristics or the rules for a poker. So get two pairs, ace high, stuff like that, the hand categories, and what each card means. So I'm probably gonna have to create a struct for that, I think. It probably makes more sense to create a struct. And then inside of the struct I put each pattern, I think. This is something that is confusing because I need to know the position. That's the problem here. Because it's only separated by actions. So how the hell I'm gonna know the position of each player? That's gonna be a challenge, I think. I guess I can go by rounds, right? So round number 1, number 2, number 3, number 4. See if it's the same. Or maybe in this session is also interesting the amounts here. Buying. Yeah, but so round number 0, 0.125. Okay, so this determines which ones are the blinds and small blind. Then round number 1, XX. Yeah, so it starts with round number 1, round number 0, round number 0 then. So 0 is the beginning, the blinds, and then the number 1 is pre-flop action. And then number 2 is flop and so on. Oh, so first it says the cards, and then it says the action, which makes sense. Oh, I think I understand. So the sum is the bats. Set 3. Yeah, so player 3 limps, I guess. Then I raise, I isolate them. Oh, fuck. I need to find one that has the full thing. But I think I understand now how it works. So it's separated by rounds, and then you have the cards and the actions. And then the initial thing uh, says how many chips each one has. So the stack size and yeah, but I don't understand. Maybe this is after the hand was finished already. I need to know. I think it makes more sense for this to come after because it has the bets and the how much it was won or lost, I think. But it does make a difference, I think. Oh, it doesn't make a difference on the code, but for me to think about what is the best way to filter this, I think it makes sense to understand. Or maybe this is for the whole session. So the players that won or lost the whole session. But I don't think that makes sense because there should be something that says that talks about the stack size for each round, I think. Because otherwise, how I'm gonna know? Because in poker, it does make a lot of difference depending on how wide, how big your stack size is in relationship to the pot. the strategy it changes a lot. So yeah, so I think that's the pattern. General is the beginning, and it talks about how yeah, it talks about the stack size and then the rounds. Each session is a hand. Yeah, that seems to be the pattern here. So I think I'm gonna do this differently here. I'm gonna do which tags, the sequence of the tags. I wanna do as simple as I possibly can here. I should put as little or as few information, not sure I would say that, as possible here, so it's easier to understand what exactly is the patterns that I'm looking for to extract from the file. Or maybe I should copy the whole thing here, but here. So this is number one. Rebuy. Don't understand the rebuy and add-on thing here. It's weird because this is in the beginning, but it seems like it would be better if it was at the end, because it seems that this is the result of the hand, or the beginning of the hand. Maybe it's the beginning of the hand, but it's kind of confusing and I'm not really sure, because it has the bats here. So it should be the end of the hand. But then I'm not sure if the chips are from the beginning or from the end. It doesn't make a lot of sense. Yeah, but then this. So it has the list of players here. Then the rounds. On number 0 is pre-flop. No, it's the blinds. I think this one is worth to put the number 2 here. I'm gonna put this whole thing. I'm gonna erase this part here. So players first. Yeah, I need to figure out what the chips mean. If they are the chips at the result of the hand, at the end of the hand, or the beginning. I think it makes more sense that are the chips that were in the beginning, and then the yep, and then the bets are from the end. But I don't think it matters that much because it obviously does matter, but for what I'm trying to do, I don't think it's gonna matter that much because I'm gonna do simulations for full stack anyway, which are 100 big blinds deep. But obviously in the game makes a difference. Yeah, because I'm only trying to see the frequencies that I should play at 100 big blinds deep. I think I can safe to extrapolate because there are, oh, obviously it's not really good because it's not gonna be accurate, but I think it's accurate enough that it doesn't matter that much. But it would obviously be better if I could get the stack depth of each hand as well to put on the data and to translate that into the simulations. So plan. Oh, this one. Oh, it does have cards here. So this one doesn't have cards because, well, actually, yeah, so this is supposed to be number 1. Oh, so this is the actual number 1. So actions have numbers as well. And round number 0 doesn't have cards. Oh no, it has cards. Cards equals cards here. And then after that, it shows in this format. It's also gonna be a little bit complicated as well. It's probably gonna be more difficult than I thought it would be. Biggest challenge here that I'm thinking about is how I'm gonna know how I'm gonna create an algorithm to capture the position each time. I need to understand the logic of the player's position here. Also to understand what the type means. The sum is the bets. I think that's pretty clear. Because here is the blind, so it has to be the bets. Then how do I know the position? I think it's just in order, actually. Yeah, so the 1 is the small blind, always, I think. And then it goes, obviously, up to 7, or... Actually, the actions go way beyond that. Because each thing is an action. Which makes it a lot more difficult. Because depending on how many actions is gonna be a different situation, obviously. So I can't. Maybe I'm gonna have to resort to the number of actions, but I think it's gonna be very complicated if I do it like that. Because then I have to create a rule for every. It doesn't seem like it's possible actually, because there's too many different actions that can happen, I think, depending on different bet sizes and stack depth, to take all of them into account to figure out the positions based on the actual number. But the one thing that comes to my mind is a map, but I can't map the action to the position. And the obvious thing is that the cards are the cards, and then the actions are the actions. I think that's pretty intuitive. And then the rounds are the streets. So each round shows show cards and actions. And all of them are gonna have up to 4 rounds. So that's pretty easy. The difficult part is the sums, figuring out how to make sense of the sums and how to make sense of the player's position. I think the position is the most difficult one. And also the stack size. But I think the players, I'm probably gonna use these chips here for the stack size. Each round. Yeah, each row of the data frame needs to contain each category of this. That's probably the best way to do it. So whenever there isn't a turn of river, then I put an empty string or something like that. And each hand is gonna contain the players, the chips, players, chips, the sum, and yeah, but how I'm gonna put the position, that's the problem. So players, chips, sum, and cards, and then action. So the question is how to map actions through position and streets. Yeah, I can use obviously I can use the rounds to map the streets because it is the streets. But then how do I map the actions to the positions? The obvious thing is to determine player the small blinds and big blinds. Then round number 1 should be used to denote the positions. So that's what I have to understand here. Well, I guess, yeah, obviously. I can use the round number 1 to use rounds 1 to determine position of other players based on action. Yeah, but then that's the thing. Because if the action changes, if there's more than 7 actions, the positions are going to be incorrect. Or maybe not, because regardless of if anyone raises, there still needs to be the decision still needs to go over the other players. So maybe it doesn't matter. I can go up to 7, and then that's gonna determine the position of each player. That's probably, yeah, I think that's gonna work. Because regardless of what happens, if people raise or not, it's still gonna go over each player before the action goes on. And I think it goes up to 7 because of the small and big blind here. No, let me think. Because if you should go up to 8, because if each player acts and there's 2 actions in the other round, then it's 6 plus 2, obviously. So let me think. Yeah, so here, action number 3, he raises from under the gun. Let's assume that's what happens, then middle position folds, cut off calls, button folds probably. Yeah, sum 0 equals fold. I wonder if I should put the sum as well, or if it's gonna be better. I think it's gonna be better if I use numbers. It's harder to think about it when I'm trying to reason on how I'm gonna build the simulations, but I think it's gonna be easier to actually build the simulations, obviously, with the numbers. Because Pio is probably, it probably works in a similar way. Yeah, so it goes from under the gun until small blind. Under gun, middle position, cut off, button, small blind. But why isn't the big blind action on this one? I have to be careful here, obviously, because if I get this logic wrong of how to map the positions, then everything is gonna be off in the final thing. So I think this is the most important thing to think about. And here is not taking into account the big blind, which is weird. But I think that's going to be the way to do it because obviously I can separate the conditions with an if statement. I just need to check if I understood all the possible situations on how round number 1 and round number 0. So I map the positions correctly. Yeah, here there's 8 actions. So I think when the big blind plays, it's when the big blind, yeah, when the big blind plays, then there's 8 actions, and when the big blind folds, there's 7 actions on the round 1. And this is a problem because I'm thinking how I'm gonna actually, well, I guess I can create a variable and then I can append the values here. So I look at this as a block and then I create a array or a vector and then I append the values and then after I append each one and it gets to this pattern here, then it stops and then it verifies the vector to see the length of the vector, and if the length is 7, then I map the positions like that. And if the length is 8, I map in a different way. That's probably going to be the correct way to do it. The other thing that I didn't see in the previous one, yeah, looks like here there's also this because the players on the round number 0 are obviously also being counted here because they also act. Small blind and big blind. Yeah, so maybe the easiest way is probably to filter with the position on the round 0, to filter the position round number 1 with the using the position round 0, because I know where the big blind is gonna be. Let me think. Oh, there's also the case where there are not 6 players in the table. I didn't think about that. That's gonna complicate things a lot more as well. Because then there are gonna be less actions. So I'm gonna have to structure the flow based on the players first. And then after that, I'm gonna have to. Yeah, so I think for each section here is gonna be a vector. And then from each section to the other one is gonna be a flow of if-else conditions or a match statement that decides what happens in the next iteration. That's probably the best way. So, but I'd have to think about a logic that is gonna work for each one, regardless of how many players there exist. So it can't really be dependent on the number of the action, I think. It has to be dependent on the number of players and the actions at the same time. And yeah, it's gonna be really hard actually. Because these three things have to be linked here. I have to use this one and this one to get the positions based on the how many players, I think. Oh, this has 9 actions actually. Yeah, but above 9, then it doesn't really matter because from that point I'm already gonna know what the positions are. It's only complicated below 7 because I have to think about how many players. Also, obviously, actually, the last ones are gonna be the big blind and the small blind. Up until 8, the action 8, is gonna be small blind or big blind. So if there's 7 actions, then the big blind. 7 actions or maybe not actually, because there's a situation where you have less players. That's the thing that makes it difficult. As I was gonna say, if there's less than 7 actions, then the big blind doesn't play. And then this means that the 7th position is the big blind, and the other ones I can do, it's easy to map. But then if there are only 3 players on the table, for example, then it screws up the whole logic. Maybe not, actually. Maybe it's the same. Because the only thing that is gonna change is I can count from the top or from the last one and then go backwards up until the first. Yeah, so I think maybe it's worth to write this down. So I created a struct for a round. See how many players. Then based on how many players. Create round. Round 0 is gonna be SB BB and this should be here. Yeah, so the round 1 is gonna depend on how many players exist. I get the last action. Yeah, but that's the thing. Because in case how I'm gonna know if the big blind folds, then it's not gonna count the big blind, so I'm gonna know if the last one is the big blind or small blind. Oh, actually, I can make. It gets really complicated, but I think that's it's gonna be the only way. I can make a condition that checks to see to stop or to count. So for example, in this case, let's say I have number 7 here, which is equal to this guy here. So this is always going to be, so the number 1 is going to be the small blind first. Action 1 is always, let's see. So I can make the condition to stop or to see which action it is on condition to see which action it is the SB on round 1. And then from that condition, if there's one more action, then I know that's the big blind. And but I already have the big blind actually, so I can just stop at the small blind. I have the big blind because of the round 0. So I stop at the big blind and then I go backwards until the last action. Go backwards to first item in vector. And these are gonna be structs and vectors actually. I think for each one I create a struct, and then out of this struct I create a vector maybe. This is the thing that is gonna be confusing because I don't have experience in Rust. Is thinking about how I'm gonna structure this, but I think from the fundamentals and the first principle I can already see how it's gonna work. So for each building block here, I'm gonna have a vector or something like that, and I'm gonna track the steps through the vectors. So I'm gonna use the vectors to map through the positions and to the other information here that I wanna capture, which is the sum. So the first vectors are gonna be the amount of players and the stack size. Then the round number 0 I use to get the small blind and big blind. So it's kind of gonna be a linked list of vectors. That's the structure that I'm thinking about, because each round points to the next round. And then I can use the vector on the round 0 to map the position of the players on the round number 1. And after the round number 1, so yeah, so that's probably gonna solve the positions regardless. I think that's a good way to do it, because the first player is gonna be so I need to create a counter that counts when the second vector is created, which is gonna be the vector of round number 1. And then the first action on this vector is gonna be the under the gun player, and then I stopped counting on the small blind, and then based on that I'm gonna know the positions of all the players. And from that point it doesn't matter the actions that much, because I can associate each action through the player from the mapping. So instead of saving the player, I'm gonna use this player to create a mapping to positions, and then I'm gonna associate to each position the bet sizes. So I have to think about what structure I'm gonna use because the positions are gonna be vectors, but then for each position is gonna be a tree structure because of the bet sizes. So I have to think about how I'm gonna associate this and in a way that I'm gonna be able to put on a data frame. And it's gonna be kind of like a fractal, because once you figure out how to solve for one pattern, for one session, obviously, I'm gonna have I'm gonna be able to do that over and over again for all of the sessions. So I have to do it in a way that it works for any session, for any amount of players, any amount of actions. I just run the same algorithm, and then I translate the data structure that I create into a CSV format that I can make sense of. But I'm starting to think if it makes sense to. Yeah, the question that I have right now is if there are any ways to save in a file, maybe using H5 in a tree structure way, because it's going to be a lot better and more efficient. Even when I create Pio, because in Pio is trees as well, obviously. Poker is a tree game. So it would be better, I think, if I could figure out a way to save the information in a tree format and then use that to create the solutions. But I'm not really sure how to do that. And the thing that I'm not sure about is if it's going to be worth it because of the time I have, because then I'm going to have to figure out on how to save in a tree structure on H5 file format, and I'm not really sure. So I'm thinking that it might be better to just save in different CSV files and then translate in, maybe do a mapping to one CSV to the other, kind of like a relational database, which is not very good because, yeah, actually, now that I think about it, it makes more sense to do in a NoSQL format because NoSQL is recommended for graphs and trees. So yeah, probably I can search for that on maybe GraphQL, how they um, how do they store the information. So maybe it's better to use JSON instead of CSV actually. And then I wonder if I can use polars to oh, I remember seeing on Polar documentation that they have SERD, and I'm not sure how to say it, but it's a serialization for JSON, so I think Polars works with JSON. So that's probably what I'm gonna do. Yeah, so it's probably, yeah, that's probably what I'm gonna do actually. So scratch the CSV stuff. Now that I think about it, it makes a lot more sense to do. Just save on the JSON format, and then I create a tree or graph structure using objects, which in Rust is going to be structs. So it's going to be structs and vectors, I think. So yeah, based on the stuff that I was saying. So each round is a struct, and then the struct has vectors that have match logic. The match dictates the positions and the actions. So the actions are vectors that are connected to the structs, which are the base for the positions. Yeah, so the main thing that I need in the beginning is gonna be, actually it would be good to figure out, I guess it's just a session. Uh, Session, because I'm thinking about creating in blocks. So you, it's maybe not essential, but really good to know the beginning and the end of each block, each algorithm, because I can encapsulate that in a function. So the session, from the beginning of the session to the end, is going to be the algorithm that I'm building. And that's the best way to think about it, I think. And then each round is a struct, and then each struct has a vector, and then the vectors have the match conditions that create the tree structure. And then I save the tree in a JSON format. So the beginning, I'm gonna take the players. So I'm trying to think about the steps that the function is gonna have, the algorithm. So the beginning, I think, yeah, that's what I was saying, that is better to know the beginning and the end, because I can't do things linearly here, because I have to go, the program is gonna go from the beginning, it's gonna read from the beginning through the end, obviously sequentially, but I can't do anything with the information from this here from the players. I have to it needs to go up until round number one, and then after it goes through round number one, then it has to make the decision based on the previous stuff, so that I can map the positions. That's the thing that I'm thinking about. So it's gonna read from general until here, and then once it gets to here, it's gonna create the base of the tree, which are gonna be the positions of the players. I think that's the best way to do it. And then once I have the position, then I have to think about how I'm gonna use the actions that were previously passed by as I was reading the stuff, so that I take them into account and I put each action in the correct position for each player. Yep, after I have the position, then I can just use the name of the players here to associate the actions and the stack size with them. So maybe I'm probably gonna have to use a cache and then cache this stuff. And then after I create the mapping, then I access the cache and then I put the actions in the on each player. So actually it's gonna be a dictionary of dictionaries, now that I think about it, because each action has to be associated with each street as well. That's what makes it complicated. Because once I have the mapping, so I'm gonna have the mapping of, let's say, player Pichu is 3 big blinds. Or actually, I'm not gonna do it sequentially, just so. Yeah, so that's gonna be. It would be better if I did the other way, actually. Yeah, so this is gonna be the thing that I'm thinking about in the beginning. So it goes over these things first. First, I get the yeah, but each time is gonna be the same, so it doesn't really matter that much the names here. Yeah, but I have to cache. So the first thing I'm gonna cache the chip sizes through the players. But that's the thing that I'm not sure about. What's the size of operations here? Because the chips need to be associated with each player, and the position needs to be associated, and the streets. But the streets, I think, maybe they can be associated outside of this, where each action maps to. But then I think it gets more confusing. Let me think about it. The way that I picture is each player kind of like has a tree structure that identifies the actions. Or maybe not a tree structure. I can put the actions for each one, for example, like this. And then each one it would indicate, but then that's the problem. Yeah, that was what I was thinking about. Is how I'm gonna know because I need to map each action to each street. That's the thing. So I think it's gonna be better if I do this flop like this, something like this, where each street, each position maps to each street, and then on the street has an array containing the actions of each player. But then the problem is I don't, just with that, I'm not gonna be able to know which player acted first. I guess I can create the heuristics based on if-else statements, based on positions, but it seems really complicated. maybe there's an easier way to do it. Because obviously, if I know a player is on the button and then I can count the actions of the player on the button and the other players, and then I can figure out based on this this all the actions which ones comes first. But it's obviously really complicated to do it this way, I think. There must be an easier way, I think. Yeah, the key here is how to translate the actions into the tree structure. So how to translate a vector of actions into a tree structure, taking into account the positions of the players and the streets. That's the main challenge here. It's an algorithm data structures kind of thing. And now it makes a lot of sense to me, actually. I think I'm getting more and more. Uh, I'm understanding more and more the patterns of thinking of a programmer, on how to think about things in a programmer's way. I think because that's the fundamentals. I think it's all about data structures and algorithms, and the the algorithm is going to be the byproduct of the way that the data structures interact with each other, which maps out the geometry of the patterns you're trying to create, which is an electromagnetic field of computation that achieves a certain result because it creates a gravitational force, I think. Everything is kind of linked. And it's obviously worth to spend a bunch of time on this because it's going to dictate every decision that I make. I think the rest is just details. I can just search for how to do each thing on Rust. It doesn't really matter that much, just syntax. But thinking about this is gonna make a tremendous difference, I think, in the way in how hard it's gonna be or how easy it's gonna be to build everything. So it's probably the most important thing that I have to think about. And after I figure this out, then I can just follow the logic that I created, and I think it's gonna be pretty easy. So the main thing that I'm thinking about here is which way that I map this thing here, this relationship between positions and streets and the actions of each player. The intuitive way to think about it as someone that is playing is to think in streets. Yeah, link the positions to streets, and then each street is associated with the set of actions. But what I'm trying to encapsulate here is also in position, because in poker the key principles are position, bet size, stacked up, street, and the type of pot, which is dependent on the actions of each street. So if there's a raise and re-raise pre-flop, then it's a 3-bet pot, which is a category. If it's just a single raise pot, it's a different category. And you play, the logic is going to be different depending on, obviously the principles are the same, but the logic changes because of the stack size. So the function of polarity in poker is intrinsically connected to stacked up. The lower the stacked up, the more polarized ranges become, because that's the game theory of the game, the logic of the game. So the shorter the stack size, the more incentivized you are to polarize, which means that you're either gonna have value or bluffs. And then the bigger the stack size, the more merged they say you need to be, which means that you're gonna bet weaker hands because you don't want to increase the size of the pot too much because of the potential of future cards coming and changing the value of hands. So you need to balance your range, take into account weak and strong hands to get the maximum value of all of them. And obviously it's going to be based on the aggression of each player because there's compound effects on each street you play. But usually the three of categories are based on position and then on the actions of each position, and that's going to determine the classification of the hand in the way that you study manually in PySolver. So I think the closest as I can replicate that is going to be easier to translate that into building the simulations and getting the statistics out of it later. But the key question here is how I'm gonna know, because the amount of actions are arbitrary. They're gonna change each time. It's the same problem that I had there with the logic of the players, because the amount of players can change each time. But then I think this is a pretty robust logic using the small blind from the first round, because the small blind is gonna be constant, and there's always gonna be, well, maybe there's only, what if there's a hand that is only a big blind? But I think that's gonna be an outlier, so, and it's gonna be very infrequent, so it probably doesn't matter that much. So I think that logic is good enough to use the small blind as the constant in the round 0 and then map the positions based on the small blind with both round 0 and round 1. I think that's the best logic. So now here, there's probably something similar, because that's how everything works. There's always constants and variables, and reality is the balance between them. So, oh, there's also a really good video that I saw. Maybe I can open, because this thing about constant and variables remind me of that. I think I'm gonna open the video here just to show. Yeah, but there's gonna be a constant based on the actions that allows me to structure the variables in a way that is robust. Let me see if I can find the video. Yeah, here.
This theory of everything is about the unification of opposites.
Yeah, it's a really good video. I highly recommend. But here he talks about this stuff that I was talking about, which is you always have this symmetry here. The only thing that I think differently about him, this is a theory of everything from this guy's perspective. And he goes over the polarities of everything. And I agree with him in a lot of stuff, but the main thing that I disagree, I think, or maybe not disagree, but I see that I think he didn't mention here, is that this symmetry and this polarity is always relative to the observer, because you can only have symmetry if you have a perception. So all the polarities are multifractal geometry, because they're interconnected with all the other polarities, and the symmetry that they have is the illusion of the self, which creates the geometry of the object. But here he talks about this, which is there's always variables and constants, and that's the mathematics, and in relationship to the experience of a human being. And I agree with that. So I think I'm using this principle here to think about this, because here is exactly that. This is exactly what's going on here, where you have the constant, which is the small blind, and then you have the variables, which are the positions and the players that change each time. So the best approach is usually going to be the one that encapsulates both sides of the polarity simultaneously, because that's the place of highest balance in relationship to the perception that experiences the illusion of symmetry in multiple relative polarities. So there must be something similar to that in here, but I'm not being able to think about it. Because the actions are the variables, I need to find a constant that is capable of allowing me to create something that is robust in relationship to how the actions are going to deviate. So maybe I should think about edge cases, or what happens with different amount of actions. What happens with when someone checks or when someone bets and then gets raised and then they re-raise. The number of actions is gonna be different, but the street is gonna be the same. And that's what makes me think about this relationship here. But then the other variable is the number of players, I guess. So that's the other thing that I wasn't thinking about here. So if there are 3 players on the flop, it means that the it's also going to be intrinsically correlated with the amount of actions. Yeah, it's kind of complicated. I can think about now how to do it, but I'm trying to think if there's a much easier way to do it. Because obviously what you can do is you can, based on the length of each one, if I do, for example, like this, let's see, 145. The numbers are the amount, the sum here for each player, are pretty much how much they bet or thing like that. So let's say it's like this. So in this situation, there would be 3 players on the flop, and then the actions of them would allow me to see the flow here. But that's the problem, because one thing that can happen is that the small blind can donk. Donking is when you lead with a bet after calling the previous street. So if, let's say, if the early position raises and the small blind calls, if the small blind bets on the flop, then he is donking. That's what it means. So this is the biggest challenge here that I'm having, I think. Because if the small blind donks, there can be the same amount of actions, but then it changes the whole dynamic of the game. And I have to figure out how to separate these 2 situations here, which I don't think I can do only with the number of actions. Because even if I use the sizes to create some heuristic that is going to change, it's still a very weak logic, I think. I need to find something more robust that allows me to see the line of the situation. Because that's the other thing, that's the other principle that you use when you're studying poker, which is each line you're going to study differently. So usually the way that is represented is with X and C. So this line, for example, would be when you check, call the flop, as the small blind, for example. Say you're on the big blind. You check, call the flop, and then both players check the turn, and then you bet on the river. And this would be the float line. And then you separate multiple different lines based on that. Let's say it can be big blind again. And here you check raise, and then both players check, and then you bet. So ideally, I have something that I can create the logic here, or the heuristics that will allow me to map the action with these lines here, because that's the main goal, I think. Essentially, what I want to do is, after I filter this and I build the CSVs, and I'm gonna build the simulations, I'm gonna separate the simulations by line, and then on each line I'm gonna see the percentages. So for example, let's say based on the data that I can see that I'm check calling 33% of the time on the flop when I'm the big blind. Then I can build the simulations, and let's say my opponents check call 50% of the time. I can build the simulations, and then I can see how Pio Solver would play against them. So let's say that I realize that I'm checking raising them, or that I'm betting in position 30% of the time, and after I build the simulations with Pio Solver and no lock the strategy of calling 50% of the time, the Pio bets 60% of the time. Then I want to create something that allows me to see statistically that in which line and each position, there's a percentage difference between the way that Pile Solver would exploit them and the way that I'm exploiting. And then that's going to be, I think, the easiest way and the highest ROI I'm going to get for the amount of study by understanding the percentages of where I should deviate more. So when I'm building this, I'm trying to think about it in a way that allows me to map these lines here with the logic that I'm building. So later on, when I build the simulations, I can connect them directly with the lines and the positions. But it's extremely difficult. I think I'm gonna have to think a lot more. And there must be a way for me to, because the lines are not so difficult, I think. The key thing that I'm struggling with is the thing about the amount of actions and the amount of players on each street and how I can think about the line based on that. That's the difficult thing here. Oh, obviously, or maybe no, actually. I was gonna say that I can look at the sum and then actually, yeah, that makes sense. Because if the small blind donks is gonna be, the sum is gonna be greater than 0 in the beginning. I forgot that the actions are linear, so yeah, actually I think that works out actually. Because I can see based on the amount of actions and I can create a if-else statements. So I'm gonna map the lines with if-else statements, I think. So I need to think about yeah, the lines are if-else statements are that makes a lot of sense. So each line is gonna be an if-else statement, and then the amount of actions are gonna change the lines. I think I'll be right back. Now that I think about it, it makes so much sense because the size, the if-else statements are the trees of, are the branches of the tree of the game, obviously. So the amount of actions determine the depth of the tree and how many levels there is gonna have and how wide it's gonna be. And the amount of players are each node of the tree, I think. So each position is a node. So it kind of it starts depending on how many players is going to be the base. And then the branches are the if-else statements, which maps to the lines. Hmm. Oh, there's also the stack size that determines the size of the trees as well. But then how do I think about the cards inside of the tree? Because there's also that. Yeah, that's a whole nother thing that I have to think about. But the cards in some ways I think is gonna be easier because I can just I can create a struct for the whole deck, and then I can create another struct for the games. One struct for each, not not game for each type of hand. So one struct for pairs, for flushes, things like that, and then I can map out the cards to the. Maybe I don't even need the to create a struct for the whole card for the whole deck. I create multiple different structs with pairs, flushes, things like that, and then I map the cards to the thing, to each hand strength. Hand strength. Yeah, but now that I'm thinking about it, it's probably gonna be better to have the whole cards because then I think it's easier because there's some situations where you have cards that it's kind of hard to classify, and unless I want to create a one struct for each particular card, which I don't think is gonna be that good. I think it's better to create one for the whole deck and then use the two cards of each player to combine with the whole deck and find the range, let's say. Yeah, but that's a separate thing. Maybe it's better. Maybe I should open Skylidraw. I think I'm gonna put some music as well. I think I'm gonna open Skylidraw and draw this thing out. So the deck and the strength of hands are gonna be one thing, and then the flow of decisions is gonna be the other thing. It's gonna be the game tree. And then I map the game tree, I map the two trees with each other. That seems really complicated actually. I thought it was gonna be easier because in my mind I was gonna just parse this and then put on the CSV, like create a bunch of different columns depending on the information that I want to get here. But I just didn't. I didn't hit my mind that. And obviously I know that poker is a game tree based on the simulations that I've done, but for some reason I just didn't think about that. After I figured this out of how to structure the actions for each line, then I'm gonna start coding, I think. Because from that point I think it's gonna be easy. After I figure out what is the best way to structure the lines. I think I'm gonna erase this stuff here. I'm also trying to think about in what way I can write this stuff so I don't have a lot of information here and it doesn't get confusing. I just wanna write the absolute essential things. Maybe... Because the thing is, I still need to write what patterns I'm gonna have to extract from the text as well. Not just the logic that I'm gonna implement. I guess I'm gonna erase this stuff again and start from the beginning. Let me think about. So I need a pattern for. Maybe I leave the patterns here. Pattern for players. For player and players. Pattern for action. I'm gonna leave this on the same line. Pattern for cards. And inside of this, it's gonna be player and position the player. The sum, which is the bets. Trying to think about what is the best way to add the description of each one without clouding this stuff too much. But I think I'm gonna remember if I leave it like this. This type I don't understand what it is. And then the text here is gonna be the cards. The mapping I think is also good. Should remember. Which I did somewhere here. And the rounds I can pass here. What was the other one? Diamonds. So I have player, cards, action, round. What else? The bat as well here. Oh, session. So I think that's everything that I need. I have the players, which are gonna be used for the logic of the positions first. The cards, which obviously I'm gonna use on every round to know what each one had and to make the strength of the hand. And there's a difference between the cards of the players and the cards of the flop as well. So I need to put type here as well. Because I'm gonna filter the cards based on the type, I think. So when the type is equals to flop, then I put in a different thing. And oh, I guess that's what the type means. So when it's pocket, is for the hands of the players. Yeah, that's the difference. There's probably some logic with this type as well here for the actions. that I don't understand really well. 5, 3. Maybe there is some information about this. But I think it's find it hard to believe that there's gonna be anything about it. Or maybe there is, but because these hands I think are from older manager, but I don't think I'm gonna be able to find anything that explains the format, the way that is structured. Man, history actually. It's obviously possible to do it because the older manager does it. Another software that allows you to analyze your hands, so I don't see why it's definitely possible to do what I'm trying to do. This here, the cards in the action, I also don't understand really well. Yeah, it doesn't look like it's that useful because the cards show here already and this is always empty, so I'm not sure what's the point of having this here. The other thing that I'm not sure is the chips. Oh, I can see the button from this thing as well, the dealer, obviously. When it's 1, it's gonna be the button, the rest is 0. But that, I don't think it makes a lot of difference because I already thought about the logic on small blind and big blind here to figure out the positions of all of them. Oh, the only thing actually is the big blind actually, now that I think about it. It's gonna be hard because I'm gonna have to think about the condition for the big blind. So if there isn't any action after the small blind, then the big blind is the player that the remaining player, because all the other positions are going to be figured out from the small blind backwards to the under the gun based on the actions of the first round. And then when there is an action after the big blind, then obviously after the small blind, then obviously that's the big blind. So, but I still think it's going to be tricky to actually code that in Rust, for me at least. Let's see if I'm missing anything else here. I think I got everything. So these are pretty much everything that I need actually on this thing here. Just making sure before I erase stuff. 5, so yeah, I think I'm gonna erase this stuff here. I think I can erase this because I'm gonna remember. I'm just gonna I'm gonna think about, I'm gonna write this thing down here to think about what the final data structure is gonna be and how I'm gonna save this data structure. I think I'm gonna save it on a JSON file probably, and it's gonna be a dictionary of dictionaries with vectors, I think, probably. And that's the hard part. This should be easy, I think. Not easy, but I can see how I'm gonna do it. I just put the match condition for these patterns here. And then I extract the information based on the match conditions. But the challenge is how to structure the information that I get based on these patterns to create what I want to create. Yeah, I think the actual lines are gonna be better to do it after I already have the file saved. So from the file, from the data structure of the file, I map out the actions after that when it gets time to build the simulations on PySolver. And then based on the simulations, then I can extract the percentages based on the lines. But I think that's everything that I need here. Oh, hero is obviously... Maybe I should write this down. Hero is obviously me. And I'm gonna use that to build the simulations, obviously. That's... Yeah, maybe it's better to actually think from the end, actually. Like how I'm gonna build the simulations. Because one thing that I can do as well is simulate based on the other players and not myself. So pretty much get the data for them. But obviously I'm gonna be involved in each hand because it's my hand history. Yeah, but I think I'm gonna create simulations regardless of whether or not they played the hand. I think that's better. Because I don't wanna know... maybe not actually, now that I think about it. Because the best thing would be for me to know how I should... that's the thing, because the data is only gonna be useful if it's connected with my actual experience of playing. Because obviously the game is super complex, and if you try to get just general data and then the solutions, it becomes really hard to apply the data, because you're not grounded into your intuition, what you actually do in game. Because that's how you improve, at least from my experience. You have the intuition of playing a bunch of hands, and then when it gets to the spots, you're gonna have in your mind, you're gonna know what action you usually take on that street. And then if I have the percentage of the data, the stats, and I know that, for example, in the river, I should raise, PySolver recommends to raise, it's gonna be a lot easier for me to remember that if the data is connected with what I actually did, in the way that I actually tend to think. Because then it comes the intuition, you can feel it, like here I usually bet or I usually fold, but then I remember the data, the percentage saying that I should do something else, and then it's gonna be easier for me to remember that and apply that. So I think I can filter through based on the player here, based on hero. So if the sum is 0 or less, or 0, if the sum is 0, maybe not, because there's the situation when I'm in the small blind. Oh, so basically if round 2 doesn't have hero, or maybe the sum is 0 for round 2, then it means that I folded or I'm not part of the hand. But Yeah, actually, not sure. I think that makes sense actually. Because if I don't bet, I have to call. But what if both players check? That's the thing. Then the sum is gonna be 0 and I might be part of the hand. Yeah, how do I classify hands that I played? It's another question. But I think I can do that later actually. So I think I can get all the hands, because the hardest part is gonna be hardest part is actually structuring everything. Once I structure everything and I have the simulations, it becomes a lot easier to think about how to filter for my hands after that. So I can do all the hands and then after that I think about it. So let me go back to thinking about, now that I have the things that I want to filter already, the patterns that I want to filter, now I have to think about how to structure the data in the way that I'm gonna be able to use it for the simulations later. Let me see. Yeah, that's the hardest part. How the hell I'm gonna... I guess I can do it based on the actions, because the stuff that I was talking about earlier, that if the player donks, then the sum is gonna be greater than 0 on the first action of the... I wish the actions were starting from 1 or 0 in each round. It would be a lot easier, because this way I have to break it down. It becomes a lot harder, because it changes every time. Yeah, I can create a count variable based on the amounts. Yeah, I think for each round I can create a block or something like that. And then I can create a count variable that keeps track of the actions inside of the block. And I use that to create the lines. And what makes this a lot more difficult is that I have to think about everything in Rust, which I'm not used to doing. So I'm trying to think about how I'm gonna, if I'm gonna use a struct or a vector, what I'm gonna do to keep track of these things here. I think I'm gonna write the struct for the positions. It's gonna be a string. Throw positions. So button. Let me see again. Actually, the string slice probably. It's probably... I can just change it later. And then I copy this. Let me think which is the best way. Probably big blind here first. Start from the big blind, then button. Cut off. Yeah, probably this is the best way to do it. I never use structs, so it's hard for me to know when or if I should be using it or when to use it, because I don't know really well. That's how I'm gonna connect this to the other stuff that I was talking about. I have to map the players to that positions. Yeah, how I'm gonna do that? Maybe I'm thinking in the wrong way actually. Because you create only one struct. I'm gonna do that positions, decomposition. Oh no, actually I think it's the right way. So I create the position in the beginning and create it like this, and then I map each position to each player. So I think that's correct. But then each player is gonna be a struct as well. That's what I have to think about, because each player is gonna have the decisions, but I don't think I can make it a struct because the decisions are gonna be, the actions are gonna be arbitrary, so I can't put a fixed amount. But maybe actually I can, because I can map each player for flop, pre-flop, flop, turn, and river. So each player is gonna be a struct. Yeah, that makes sense. I think that's probably the best way to do it. So hopefully it works out. Otherwise, I'm gonna have to do everything again probably. There. And maybe it should be caps lock. Yes. Oh. Whatever. Okay. I'm not sure if there's a standard. I assume it's probably... Yeah, let me search. Here is everything. Small case, lowercase. I think I'm just gonna do lowercase everything. Just ignore the mistake here. And then this is gonna be string as well. String slice. Turn, string slice. And then river. Yeah, so each block that I parse, maybe I should create a different function as well. because then I can encapsulate the session inside of the function. And then inside of each function, so I keep track, well actually, yeah, how I'm gonna do this, I think. Because as the program reads the strings, it has to start caching information from the beginning of the session until the end of the session. So maybe it's not that useful to create a separate function because I have to cache information anyway. But maybe it is because then I can put all the logic for what to do with the information after the end of the block is reached. And then I can call the function each time it hits the end of the session. Oh, I just lost the thing again. Oh no, it's here. Let me think. Yeah, so the beginning of the session, I'm gonna create the position struct. Then, based on the formation, based on the rounds, I'm gonna have the positions. I'm gonna map the positions. No, maybe actually I should create the players first, based on the players. On this part here. Yeah, this is the first one that comes. Just trying to make sure that this session encapsulates the... Yeah, maybe this session is not a good way to keep track. Maybe this general here is better. General. Yeah, but then there's some edge cases here or some deviations. So how can I keep track of each round of bets? Maybe actually the players is the way to do it. I don't need the session. So each time I hit the players, this thing here, it means that a new round of hands started. I can't use the rounds, I think. I can, but I don't think it's a good way because they're gonna change every time. So... in general, I also think that it changes sometimes. So maybe using players is the best. So every time I hit the players point, I'll create 6 different structs with the players. So player 1, player 2, player 6, and so on. It's gonna be the player. But then I wonder, I don't think I have to initialize with any values, but maybe I'm wrong. Yeah, then after I have each player, then I make the... So the thing is how I'm gonna capture... Actually round 0 I can already select based on the player. I can filter with the action and then change the value of the player. Yeah, now that I'm thinking about it, I should probably put name as well inside of the player, so I have just something to compare with on here, because I'm not gonna be able to use the name of the variable to compare, I think. So I'm gonna put name here, because that way I can put, for example, hero here, and then I can use this value to filter, to match based on the rounds, and then I have the position. No, but let me think. Yeah, so this shouldn't be a string, it should be a player. And this should be okay. I wonder if I can do this though, because it's kind of like an inheritance, and I don't think that. But it's not really an inheritance, but it's similar. I don't think Rust supports that, but maybe it does. Yeah, that's what I'm thinking here. Yeah, create the players first, and then I map the position, because there's only gonna be one positions for 6 players. So I change the value of the positions based on the players. Let me see if I need to initialize the player with the values. Yeah, that's the problem. I need to initialize the struct with the values already. Oh, maybe I can initialize with null or an empty string or something like that. Yeah, but then I think it's gonna give me a warning or something like that, because I'm putting the player type here. And that's really confusing. Yeah, I think this changes everything the way that I should do it. Maybe by the time I initialize the position, yeah, but then either way I'm gonna have to change at some point. Yeah, but then I think I can initialize the players as an empty string, because an empty string is probably a string slice. It probably works as a string slice, and then I can change the value later. It's easier than, and then when I initialize the position, I already have all the players, I think. Yeah, but then how I can use a vector to keep track actually. Because ideally I would update the positions as I discover the rounds here for. Because otherwise I have to think about in what sequence I'm gonna put the players on the vector. So after the vector is full, I can use the index of the vector to create the positions. It doesn't seem like a very good approach. So how should I do this? Maybe it doesn't make sense to make a struct out of the positions. I'm thinking about whether or not I'm going to implement functions as well for each player, but I don't think I will, so I don't think the implementation is going to be it's going to be necessary. Because the actions are not really, maybe, yeah, I don't think there are functions actually. better to put in a vector the actions. The thing is that the problem here, I think, is that I'm thinking on a object-oriented approach, and Rust is the composition approach. So I have to think about how to shift the way that I'm thinking now into a more composition approach, because the way that I'm thinking about is nesting objects. So nesting the players with the positions and the flop. And instead of that, I need to think more about the composition approach, which I don't remember really well. What are the fundamental differences? So the question is, how should I think about the composition approach to this problem? That's what I need to think about. I think I'm gonna watch a video about this. I enjoyed this guy's videos. He's really good. I think I'm gonna watch both of these videos again. I'm gonna grab some water and I'm gonna watch these videos later. After, then I'm gonna and then I'll go back to building the stuff. But I think I'm making progress. Even though I didn't write much code, I think it's a lot more clear now in my mind what I have to do and how to structure things. Maybe I should start with the filtering stuff first, but the problem is that they're both connected, because obviously the logic and the information that I'm gonna get depends on the filters and vice versa. The order of operations is gonna determine how I'm gonna filter things and what I'm gonna do on each filter. Each filter is gonna be an if block, I think. And then inside of the if block, I put the logic to extract the information. So maybe I should actually start. It's probably gonna be easier actually now that I think about it. Just to start with these patterns here. So that's probably what I'm gonna do next after I watch these videos. I'm gonna structure a series of if-else conditions based on these patterns here to see if I can extract the information. And I'm gonna append them in a vector or something like that, just so I can print, to see if I'm extracting the correct way. Then after that, I think about what logic I'm gonna put inside of each one. And that's probably the best thing to do, because it's gonna clarify and make things easier to think about on what I'm gonna do next. So create filters for each pattern. Puts on series if else blocks. Puts the info vector. It's the vector. This is what I'm gonna do. I'm gonna grab some water, then I'm gonna watch the videos, and then after that I'm gonna create this, and then I'll think about the rest. So right back. Right, I'm back. Watch this shit.
Object-oriented design for software applications. And we've talked about inheritance at length because inheritance occurs
3x.
whenever an object is created. But using inheritance as a design model may not be ideal. When many students first study object-oriented languages, they often think that using inheritance is the only way to create classes. Not so. In this video, you're going to discover that a design model called composition may be the best strategy. So we're going to use some examples of robots and animals. However, these represent much more complex classes that we might be asked to create when writing software for an organization. Because we're using an object-oriented programming language, we first try to organize all our data into objects. Now, not all problems will lend themselves to this type of repackaging. And this is why object-oriented design sometimes falls into some criticism. Not all designs may always sort of fit this mold. But for this video, we're going to go full steam ahead in creating our first object-oriented project. I encourage you to create all the modules and run the code along with the video so you can get a better feel of how this works in Python. So our boss wants us to create many objects. So we're going to start out by just a couple templates that we're going to use. We're going to create dogs that bark and cats that meow. So we start our design by creating these classes. Here we have our two classes. We want to be able to create dog objects that bark and cat objects that meow. So we start by creating a couple classes which are very simply represented by the software. So we've got Snoopy and we've got Garfield. And if we want Snoopy to bark, we just invoke the bark method. And Garfield meows by using the meow method. But now our boss has told us that, well, we want both these objects to also be able to eat. So now we need to modify our templates in our design to create new dogs and cats that not only bark and meow, but that both eat.
Let me just check if I'm still streaming because of the stuff that happened in the beginning. Okay. I'm not really sure if the chat is also connected with the YouTube. That's the other thing that I have to see later.
So we can look at adding the eat method to both cat and dog, but all of a sudden something doesn't seem quite right. What happens here is that we now have to duplicate methods in each of our classes, and that's not really optimum. The reason is we want to make sure that if we're creating these modules or these methods, and these could be quite complicated, they could get out of sync. Maybe I mistype one, or perhaps I make changes in one and I forget to make changes to the other. We can sort of show that here, where yes, we could add those methods to each class, but as you can see here, we've already gotten out of sync. We made some typo error. It's not good to have the same method duplicated this way in multiple classes. We look at solving this problem by using inheritance. And so we're going to create an animal class with eating as a method. We can now remove the eat method from dog and cat because they're going to become subclasses of animal. This is an inheritance relationship, which we've worked out before. Inheritance is what's sometimes called an is-a relationship, and it works whenever things are what are called tightly coupled to a superclass. So a dog is a type of an animal, a cat is a type of animal. So that most of all the properties of animals that get inherited down to dog, that's a good thing. And there may be one or two differences that we specify at the subclass level. Now, how we would do that in code is shown here. So we have a class animal, which is the superclass.
It doesn't really work that way in the thing that I'm doing because a player is not a position and a position is not a player. It's a different type of relationship. That's also one of the reasons why I think that composition is probably better.
And dog and cat become subclasses because they're based on animal. Now, the advantage here is that we only have one eat method, so there's no chance of it getting out of sync with anything else. We simply need to maintain that one method. Let's look at how we would get this to work. So we'll create our Snoopy, and as before, Snoopy can bark, or Garfield can meow, but because of inheritance, Snoopy can also eat. Our boss now wants to create new types of objects. And now we're going to create some robots, some cook robots and some clean robots. Obviously, robots that can cook or clean. And to do that, we would use the same model as before, where we have these two templates. And so my robot might be an instantiation of clean robot, and it cleans by calling that method. Now the boss then comes back and says, well, I forgot that these robots have to move, so we've got to make sure that both those classes have the ability to move. And if we look at that change, we run into the same problem that we originally had with the dogs and cats that eat, is that we could put move in both these classes, but that's not a good design decision. We want to make sure that we only have to maintain one method. So again, we look at inheritance as solving our issue. And so we look at creating a subclass, removing move out of these subclasses, creating a superclass called robot that has the move method, and removing it from the subclasses. And so a clean robot is a robot, so this inheritance makes sense. So as we review, the inheritance design model creates subclasses based on superclasses. And how we would do this in code looks something like this. And so we'll look at our instantiation of this. So we're creating Rosie, which is a cook robot, and Rosie can cook by using that method, and Rosie can move by using the move method, which Rosie inherits from the superclass robot. And you're feeling pretty good about your object-oriented design paradigm. You've got inheritance working really well, and everything's fine. And then your boss comes back a week later and says, hey, we need a robot that can clean, move, bark, and play games. So we're going to create a personal robot. The reason for the barking is to keep away predators. When you're not home, play games to keep you entertained. And then we said, oh my goodness, how do we do that? And how do we make everything fall into this package which we have of our inheritance design system? Because I need a little bit here, a little bit there. How am I going to make this inheritance model work? Well, you're not. Let's recap the type of things that we want here. In a short way, we have a dog. And then we're going to look at the things that the dog has as properties. What does it do? Well, it can bark and it can eat. The clean robot moves and cleans. We want the superbot, which moves, cleans, barks, and plays games. So we're going to solve this. Well, here's where a composition can come to our rescue. And so what we're going to do is we're going to make each of these things, these skills, a class, and we're going to compose a new class by including objects from these other skill classes that we created. So let's look at how this works. Sometimes composition is referred to as a has-a relationship. So we have inheritance is a, like a dog is an animal. Composition has a characteristic such as it can eat or it can bark. How do we apply that? Well, I start by
so in my case would be the player has a position. Makes a lot of sense. And this is exactly what I'm trying to do.
Very simple classes with these characteristics. So bark is in a class of dog and it can wolf. And I'm not creating all the classes here, just the ones that will create our superbot here. We've got a robot that can move, so we define the move method inside the robot class. We've got our clean robot, and it's got the clean method. Now you'll notice that none of these are using inheritance. There's nothing here that shows they're inherited on anything else. So now what we want to do is create our superbot. And our superbot has some of these skills if we look, the move, clean, and the bark, which we defined before because we use these in other objects. And the way to do this is to create an initialization overridden method here that creates objects inside it. So this class has its own objects. And it creates an object. I use O1 here for the first object. It's created a robot object. And what can a robot object do? It can move. It's created a dog object which can bark. And it's created a clean robot object that can vacuum. Again, we're not using inheritance here, we're using composition. So we're creating our superbot and we're including objects which come from other classes. Now this class has something unique in it. It can play games. So You can play chess as one of the games. So how are we going to use what else we have to define in our superbot here? We have to define these other characteristics that can do. It can move, arc, and clean, but we can get those from the objects that we've included in the superbot up here. So we define a move, a bark, and a clean. The move comes from this object up here, gets from a robot, and what we're doing is we're getting this move method. We're calling this move method that comes from a robot class. We're calling the bark method, which comes from the dog class, and so on. So we still have to define these in here, but we're calling them from these classes up here. So if I want to change the way the bark works, I do that up here, and it gets changed down here because this is referring to objects based on this class. Now let's see how we use the superbot, and let's see how this works. Here's our complete definition. We want to create Henry. Henry is our superbot. And if we want to get Henry to move, we simply need to call the move method, and Henry moves. Henry can also bark, play games, and clean. And if we want to change the behavior, we go up to the class where the method is defined. We have to, of course, restart this based on our new definition. So we're going to create Henry again.
So I think in my case, it's pretty much the same, but then instead of superbot will be the position here. And then each position has the players, which are these ones. That's the pattern, I think. So I think the way that I structure is probably correct. But it's very similar. It's kind of difficult to separate because it's very similar to inheritance in a way, but it's not the same thing. Obviously, there is no classes in Rust, so. But I'm trying to think about it. Trying to reason about what is the fundamental principle that makes the difference there, so I understand how to write this stuff. The biggest issue is the initialization there, which I'm unsure about, because I think I have to initialize them with the values already. So, and obviously, if I make the flop the board category, maybe that's the thing that I have to change actually. Instead of putting the pre-flop, flop, turn, river inside of the player, I should put them outside on as another struct called streets or something like that. That's probably the thing that needs to change here. That's the question, I think. How do I link the streets with the player and positions? And then based on those, all of those connections, how I'm gonna put the actions that are gonna connect all of them as well. Where do the actions fall? Probably into the player would make a lot more sense, but maybe I remove this and I put on a board here. I think that's what I'm gonna do. Not board, actually, streets. And then I put this here. And I remove from here. And then here I put action. And I make it equal to a vector. I'm not really sure how to do vectors. It was something like that. Or standard vector. Something like that. Yeah, but then it's difficult because then how I'm gonna link the actions to the flops in the position, the streets in the position. If I make the actions equal to a vector for each player. That's the tricky part. It's how to connect all of them. So it's back. And this would be a number, really. And maybe it's better to, or to put a bigger number because I guess I can, the size is not actually gonna be too big. Maybe 128 works. It's always confusing for me to think about the bits and transform into decimals. I always get confused on which one holds how many numbers. I think 8 bytes holds 256 up until 256 if it's an unsigned integer. if I remember correctly. So probably 16 is enough to handle all the bet sizes. Safe in case everyone goes all in, and then let's say that each player has 100, just to be safe. Then it's 800 or 600. So 16 times 6. Yeah, so probably 32 actually, or 24 if it is possible. It's 24. I think I'm just gonna put 32 because it doesn't matter that much. It's not like it's gonna make a huge difference. In this case, I think. So maybe what I can do is create another object that connects all of them together. Can make it a game or something like that. And then the game is gonna contain the information of the tree. Maybe that's what I should search for. How to create a tree structure in Rust. It's probably, well, there isn't an object, so in Python, I remember it's with objects that you create. So each node is an object, and then the object has the lists of the levels, if I remember correctly. But in Rust, I'm not sure how this works, so I'm gonna search for that, I think.
And now, when handling arcs, he exhibits the new behavior. So this is called composition. There's no one rule for what design method you should choose when you're solving problems. The problem is going to define how you go about choosing a design model. Most people, however, feel that use composition when you can and use inheritance only when you must, because there are a lot of batches with inheritance. As soon as you inherit things from super.
I think the ranges work better in a graph format because of the way the pile works. It's just a graph, and then the decisions are a game tree. So it's a tree and a graph, the main data structures, I think. And then each thing that I'm doing there with the structure are the nodes, I think, of the graph and the tree. So the tree gets translated into the graph, which is the ranges, or are the ranges, and vice versa. The ranges are translated into. So each range can be viewed as an overall graph that has multiple different trees, which are the decisions of all, and that's the geometry of the game, let's say. Because each range is gonna represent all the actions that happens inside of that portion of the game tree. So the collection of trees is the graph that represents the ranges, and each tree represents a specific line of action, I think, or a specific position, or something like that. Oh, there's also sizes. But sizes I'm not it's probably not going to be that difficult because it's just a number and falls into place. Sizes and actions is pretty much the same thing because each action is going to be one size. Yeah, but if I'm going to create the ranges, I'm going to have, yeah, that's going to complicate things a lot actually. Because if I'm thinking about the ranges, then I need to get the collection of actions that give me the distribution of bet sizes based on the data. That's the thing. But I can do that in the end, I think, because once I have all the structure and I have all the information in a file, I can go over the file and then filter based on the positions and everything like that. And then I get the sizes based on that. Because the other thing that I'm thinking about is that it's not going to be worth it probably to create simulations for each specific hand, because otherwise I think it's just going to take too long because there's too many hands and so it's too many simulations. So I'm going to have to, maybe, yeah, now that I think about it. Because I remember studying this in the past, and I remember reading and watching videos about Monte Carlo simulations, which there's a guy, I forgot his name, I think it's Brown or something like that he works for Facebook, I think, and he did a paper on an artificial intelligence that plays poker. and it was based on policy engines. So maybe what I should do is read the paper actually, now that I think about it. So it's gonna connect everything together. And it's probably a very good idea now that I think about it. So read his paper and then I try to implement the paper. Because what I'm thinking about it now is that I'm gonna have to create an abstraction that reduces the size of the simulations so that I have archetypes of simulations that I can run. They're gonna reach the maximum amount of, they're gonna be general enough, but not too general, where it still captures the essence of the data, but it doesn't, it's not too specific that I'm gonna have to run a bunch of different simulations. Because it goes back to what I was saying in the past, that everything is a symmetry. So the poker works in the same way. There are archetypal patterns in poker that are the gravity of the game, let's say. And what changes, the specifics that changes are the bet sizes, which makes the unique nodes of the game trees. But the overall general information of the game, it follows archetypal patterns, which are fractal patterns. And I think that's how the simulations are going to work as well in the tree structure. So the question is how to find the main branches so I can create the data based on the main branches. So I can simplify the bet sizes and create pretty much find the function that correlates the optimal amount of simulations based on the general bet sizes and streets, so I can simplify the game and build the simulations based on that, so I can exploit. And that may remind me of the Monte Carlo simulation, and because I think it's pretty much the same logic. That's what Monte Carlo actually is. It's pretty much what they did from what I remember from the paper. Instead of analyzing the whole game, you create the trees, subsets of trees that create this abstraction that reduce the complexity of the game based on the policy of the agents and makes the algorithm faster. But I think that's what Pio does as well. In order to find the best strategy. But maybe studying that's gonna help me to understand or to think about how to create the simulations in the best way, the data structures and the stuff that I'm doing right now.
Superclasses. You have no choice but to inherit everything from superclasses. And you can run into a lot of problems. You can have names which clash, which are the same as names which you have in your subclass, which can cause issues. You may inherit characteristics which may be undesirable. Composition is actually simpler. It can lead to fewer problems. And most people choose composition as their sort of their default design paradigm using object-oriented languages.
I think it was Noam Brown, something like that. It was something like that. Intelligence. Yeah, I remember. Damn. It was exactly this video I think I saw from him. 4 years ago already. This one looks interesting as well. I think this one I didn't see it. The only concern that I have about doing this is that, again, I'm not really sure how hard it's gonna be, so there might be diminishing returns in trying to do it like this. Or maybe going another route and specifying the simplifications beforehand.
My name is
And then just creating simple heuristics that say, for example, if the bet is this size, then make it as if, so for example, if the bet is 80, make it be 60. If it's 40, make it be 60. So it's just a simple heuristic that simplifies the bets towards, so that I don't run multiple different simulations for each bet size. I just have a gradient of a variation there.
Hi everybody, my name is Noam Brown. This is Joint Work with my advisor Thomas Santom, and I want to talk to you today about our AI Libraries, which recently beat top humans in No Limit Poker. This is the first time that an AI has ever beaten top humans in this game, and we recently had a paper in Science that describes the details of the bot. I'm hoping that this talk will give a more high-level picture for people that are not as technically proficient in the poker AI research, and will give you some idea of the techniques that we've used in this bot. So to start with, obviously the product is designed to play poker, but the techniques that are used in the bot are not specific to poker. In fact, they are pretty general techniques that can be applied to any information game. Now, these are not games like chess or Go, or rather, of course, games like poker, but more generally, any sort of strategic interaction that involves hidden information. For example, security interactions or negotiations. And I see this line of research as being particularly relevant to bring AI into the real world, because most real-world strategic interactions involve some amount of hidden information. Now, when it comes to imperfect information games, poker served as the primary challenge.
I think I'm gonna watch the newer ones, are probably better.
Hello, everyone. I'm Giuseppe from Evolution AI, and welcome to the London Machine Learning Meetup. Today we have Noam Brown from Facebook AI Research, who's going to talk to us about AI for imperfect information game, poker and beyond. The talk will be followed by a Q&A session that will be moderated.
The thing is, I think they did it in Python as well, so it's gonna be different anyway. I wonder if they have the Git repo somewhere, if it's open source or not.
by Michael Schuster
Probably not, actually, now that I think about it. But maybe it is.
from the Czech Technical University. So, as usual, you can ask questions using the Q&A tool.
Now, Lebratus was trained entirely through self-play. There was no team data that went to the bot, and we put 120,000 hands over the course of 20 days in January 2017. And there were $200,000 divided among the pros to incentivize them to play their best. And the bot won by an overall margin, about 4 standard deviations of statistical in about 7 or 8 days. So again, I think asking how many days did it take is the wrong measurement because from their strategy. And in 2 player 0 games in particular, not know the outcome of random processes. So that means if we were to randomize our policy, then the opponent would not know what the outcome.
Yeah, I think I'm gonna focus on the simple stuff first. Then, after I build everything, then I think about this. I think it's gonna make it unnecessarily harder. And then it's just gonna take too long if I try to implement this stuff. But maybe depending on what happens at the end, if I'm able to create, I think what I'm gonna do is probably the simple heuristics that I talked about, where I just put some values and then I simplify based on those values. If the bet size is this much, then simplify to another value, and then I create the ranges, the simulations based on the simplified version of the bet sizes. There's also a problem with this, which is that, and I remember this, is depending on the amount of RAM you have, the size of the game tree decreases significantly. And right now I think I have 16 gigabytes of RAM because I had 32 and then one, I think it failed or something happened. So the size of the game tree that I can build is not that large, and it increases exponentially from the flop. So it's always better to put less bet sizes on the flop and then more bet sizes on later streets. And I think that's what I'm gonna do, because then it decreases the size of the game tree significantly. And it's also, if you put too many bet sizes, then it becomes impractical also to study because it gets too complex. So yeah, but once I have all the data, I think it's gonna be easier to know, because then I can pretty much go over all the data and make filters to know what are the ranges usually, what are the sizes usually that people are playing on each street, and then I don't think it's gonna be that hard actually, now that I think about it. The hardest part is structuring things first.
All right, we're back.
Many of the design patterns in the Gang of Four design patterns book are based on the principle favor composition over inheritance. But what does that mean? Let's find out. If you knew you want to become a better software developer, gain a deeper understanding of programming in general, start out with subscribing and hitting the bell so you don't miss anything. If you want to separate responsibilities, create code with higher cohesion, there's a couple of ways to do it. One way to do it is inheritance. So instead of putting everything in one single big class, you create a class hierarchy of classes and subclasses, where you will put certain things in a subclass so that it will be separated from the main class. Another thing you can do is composition. That means that you're basically using separate classes to represent separate things in your application, and then each of these classes use each other in some meaningful way. It's basically the difference between the is a relationship, which is inheritance, and the has a relationship, which is composition. Even though both inheritance and composition allow you to separate responsibilities, you have to really watch out with inheritance, because that actually introduces the strongest possible coupling in object-oriented programming. And I'm going to show you why in an example. So this example is a very advanced employee management system. We have an hourly employee who is paid based on the number of worked hours. We have a salary employee that gets a fixed monthly salary, and we have a freelancer. Now, freelancer is not actually an employee, but if we consider employee as a person that gets paid by a company for work performed, then it kind of fits under that same umbrella. In the hourly employee, we have some personnel data with the name and some ID. We have a part that's about commission. So if an employee lands a number of contract, the employee gets a commission. We have pay rate, number of hours worked, and there's a kind of fixed employer cost. And then we have a compute pay method that actually computes how much the employee should be paid based on these values here. So to compute this is relatively straightforward. We multiply the pay rate with the number of hours that the employee worked. We add the fixed employer cost, and we add a commission for each contract that the employee lands. Salary employee is quite similar. It also has a name ID, it also has a commission structure, but there's a monthly salary and a percentage of time that the employee works. And then this is the compute pay method. And then finally we have freelancer, also name ID, commission, pay rate, hours worked, and then we have an additional VAT number for taxes. And then we have a main function where we create a couple of these employees, print out some information, and this is what happens when I run this example. So both of these employees earn $6,000. Now let's analyze this code a bit. There's two main problems. The first problem is that there's a lot of code duplication. I mean, our employee has commissions, contract land, so has salary employee, freelancer has this as well. There's a lot of duplication in the way that the pay is computed, so there's probably a better way to structure this than having these three separate classes that have a lot of the same code. Another issue is that each of these classes have a lot of responsibilities. For example, here this one is responsible for storing personnel data, it's responsible for dealing with commissions, and it's responsible for the pay rate and hours worked and how to compute the pay based on that. And the same goes for the salary employee and for the freelancer as well. So two problems that we'd like to solve. And you can use inheritance to do it by basically creating a hierarchy of classes and subclasses, or you can also use composition, and that's basically separating out the different aspects of what a class consists of and then combining them later on. I'm going to show you both of these techniques and also show you what the difference is in terms of coupling and how that plays along with the principle of favor composition over inheritance. So let's first look at the inheritance case. So what we're going to do here is basically create a superclass for each of these employee types that stores some generic data that's useful for every employee. And let's call that class employee. And I'm going to turn that into an abstract base class. And let's also use data classes here. So we have a data class employee. That is going to contain the name and ID of the particular employee. So I'm just going to copy this over here. And this is going to have an abstract method compute pay. And let's add some docstrings while we're at it. So now we have this basic employee class, and then obviously hourly employee and salary employee and freelancer are going to inherit from that. And then in hourly employee, we don't need this part anymore. And same for salaried employee and for the freelancer. There we go. Let's verify that this still works correctly. And it does. So now what we've done, we've used inheritance to separate out a bit of information about employees and separated that from the rest. So for this, inheritance works fine. But the problem is, each of these classes still have too many responsibilities. For example, there's both commission information here and pay information, so it would be nice to also separate that out. If you want to use inheritance, what you need to do is create subclasses for each of these employee types to have a version with commission and a version without commission. So for example, what you could do is create a class salaried employee with commission that is a subclass of salaried employee. So let's do that. I'm just going to copy this entire class and then I'll remove what I don't need. So we have the salaried employee with commission, and that's a subclass of salaried employee. That's employee paid based on a fixed monthly salary, and that gets a commission. So I can remove the commission part from the original salary employee. There we go. And then what I do in the salary employee with commission, that I just put in the commission stuff, I remove this because that's handled by the salary employee. In the compute pay, I return calling the compute pay method on the superclass and then adding the commission. And now what I need to do here in this main function is to make sure that Sarah, because Sarah is actually an employee with commission, is now no longer a salary employee, but is a salary employee with commission. There we go. And let's run this code again. We're going to get the same result. But now you see we use inheritance to separate these different responsibilities a bit more. If you want to do this for other employee types, because obviously the freelancer also has that same commission structure and the hourly employee also has the same commission structure, I would have to create a hourly employee with commission. That's an hourly employee subclass, and a freelancer with commission, that's a freelancer subclass. So I'll do it one more time for the freelancer just to show you what is going to happen. So now we have a freelancer with commission, and that's basically a subclass of freelancer, and that gets a commission. This stuff I'm going to remove. And just like in the salary employee with commission, I'm using the super class compute pay method here. So that's basically this. Remove that extra plus. And that's basically what we need to do. And now I can remove the commission stuff again from this part and remove it here as well. So now I've basically done the same thing, but for freelancer. You already see where this is leading to issues. Because one thing, we didn't really solve the code duplication this way. Because if you look at freelancer with commission, so that's what this looks like. And you look at salary employee with commission, these classes are more or less the same. Basically, the only difference is that they're a subclass of another class. This one is a subclass of salary employee, this one is a subclass of freelancer. So code duplication we didn't really solve. Another issue by doing this with inheritance is that basically for every variation that we're going to add, we're going to get this explosion of subclasses. For example, suppose you also want to have a yearly bonus that's included with the pay. Then you would get lots and lots of subclasses like freelancer with commission without bonus, salaried employee without commission with bonus, etc., etc. So in the end, that kind of approach doesn't really work. And that's also the crux of what it means when we say favor composition over inheritance. If you use inheritance too much to separate the responsibilities in this way, it means you're going to end up with this huge hierarchy of subclasses, and it's going to be really difficult to deal with. Also because inheritance actually introduces a lot of coupling. Because for example here, the freelancer with commission uses again the compute pay from the super method, so it assumes things about what compute pay does in superclass. So that's what happens when you do this with inheritance. Now let's look at another option, which is composition. And with composition, we're not creating hierarchies of classes, we're trying to separate out the concepts and then combine them in meaningful ways. In this case, we have a few different concepts. We have the employee with the employee data, we have the employee payment structure, which is either hourly or salary or on freelancer basis, and we have the commission, which is based on the number of contracts that an employee has landed. So what you can do instead of using inheritance to combine all these things, you can also create separate class hierarchies for each of these three different things and then combine them later on. What you could do in this example is create a commission class and a contract class, and then combine them with the employee class later on. So I'm going to leave this generic employee class here, but I'm going to add these contract and commission classes, and then you'll see how that works together. So first thing I'm going to do is create a commission class, and then I'm just going to copy over this part because it's going to be very similar to this, but a bit different. So we're going to have a class commission, and that stands on its own. And that class is going to have a commission amount and the number of contracts landed. And it's also going to have a, let's call this, a payment method that computes the commission to be paid out. There we go. And this we can remove because we don't need that any longer. So that's the commission class, really basic. Now let's also add a contract class. For the contract, I'm going to use an abstract base class because then we can make subclasses like hourly contract, salary contract, freelancer contract. And the only thing that the contract class is going to have is a get payment method. So let me just copy that over from this class. That's an abstract method. And let's add docstring. There we go. So now we have both a commission, we have a contract class, and we have the employee class. And now this is where composition gets into play. Because what we can do now is basically assign these contracts and commissions to an employee. So an employee is not only going to have a name and an ID, but it's also going to have a contract. And an employee is also going to have a commission. Now, because not every employee is going to have a commission, we're going to turn this into an optional type. So I need to import that from the typing package. And default that's none. And now employee actually doesn't need to be an abstract base class anymore. It can be just a regular class because that's what we're going to combine everything into one. And then the compute pay method, we simply use the methods from the contract and from the commission to compute what the pay should be. So first we're going to compute the regular payout from the contract. And then if there is a commission, we're going to add that to the payout. And then as a last line, we're going to return the payout. So what we've done now is define a relationship here between the employee, the contract, and the commission. That's basically what's happening here. And then we deal with how that interacts with each other in the compute pay method. And now what we can do is create specific contracts. So I could create an hourly contract. So I'm just going to use the hourly employee class for that and change it a bit. So the hourly contract, that's going to be a subclass of contract, obviously. And then that's a contract type for an employee that's paid based on the number of worked hours. And that contract type, what does it have? Well, it has the pay rate and the hours worked and the fixed employer cost. And let me just replace this method with the get payment method. There we go. And then the only thing that this get payment method does is return pay rate times the hours worked plus the employer cost, and the commission is handled somewhere else. This can actually be removed because that's already defined in the superclass. So now we have an hourly contract, and I can make a salary contract as well. And that basically looks like this. And then finally, let's also create a freelancer contract just for completeness. I should have copied that from the hourly contract. There we go, and there should be a fat number. So that should be it. I can remove all these complicated with commission classes because we don't need them anymore. So just remove everything here. Now there's a couple of things we need to change in the main function because now we obviously change the whole structure of the application. So we have commissions, contracts, and employees. And in the main function, we need to basically construct these things. So for the first employee, let's create a contract. And that's an hourly contract with a pay rate of 50 and 100 hours worked. And then Henry becomes a regular employee with a name and an ID and with a contract. For the second employee, we're going to do something similar. So there's a Sarah contract, and that's a salary contract with a monthly salary of $5,000. And then Sarah is just like Henry, a regular employee instance, and we provide it with the contract. Second thing that we add to Sarah is the commission. So let's create a commission object with 10 contracts landed and also pass it to the constructor.
I think the thing here is how do I transform a vector into a tree? I have to think about the right times to break the vector down. So the actions are the vectors, the vector. They go from the beginning of the hand until the end. And then I need to break them down based on the streets. So that's going to be one point where the vector becomes the nodes of the tree. And the actions. So there's two breakdown. It's kind of like you're breaking a... so you have a line, then you break the line and make different lines based on the nodes. The streets are the main nodes, and then on each street you also have the actions. But then outside of the line you have the players as well, which are connected with the nodes. So the actions are the bridge between the nodes of the... the actions are part of the nodes as well. The actions are nodes. And so the actions connect the players with the flop, the streets. So the question is, how do I do that? So maybe instead of putting a string slice, I put actions here. But then I have to create another type. I create another struct called actions, and then... Yeah, but then... Because a struct is not really good to represent actions, I think. That should be a vector. So maybe creating something separate there. There's also the positions, so... let me think about the filter first, then I'll think about this later.
There we go. Now we only need to change a few things in the information that we print because hours worked is actually part of the contract. There we go. And the contracts landed is actually part of the commission. And there's one thing I forgot to do, which is in the employee class, remove this abstract method because compute pay is not commission.
I think I get the point here.
Or specific. I mean, only for the specific versions of that.
I get the point. I think I'm gonna open SkyDraw. And see if it helps to draw the stuff out. I don't know why the color is like that. And that's weird. Oh, it's because of the... I'm using the extension here. Dark Reader. And let me go back. I'm gonna deactivate this. So I have players. streets. Positions. Yeah, I'm gonna have to do this one multiple times. Or maybe it's better if I decrease the size of this as well. I'm gonna annoy 6. Maybe it's better if I put it like this. So each player has one position. Obviously, I'm not concerned with how good this looks, just so I have an idea. These streets are not correlated with the positions, so I think I can put them here. Yeah, maybe I'll do another one for actions. The thing is, because each player is gonna have multiple different actions, depending on the situation, obviously. That's the thing that gets confusing, I think. Yeah, I guess the streets are kind of easy in a way to break the thing down. And this is the stuff that I'm struggling with, is how I'm gonna frame the actions with the streets and the players. How I'm gonna break things down so that I have the lines at the end. And the stack to pot ratio. Each player makes an action which goes towards the other players. Yeah, each player is gonna have at least one action by round, unless they're not part of the thing, unless they folded. So, which is also a possibility. Maybe I can think about the overall amount of actions instead. Let's say. Maybe this is a waste of time, but I'm not sure if it's gonna make be easier to think about it if I draw this thing out, but maybe I think it's better to think about the total amount of actions first, like up here. The problem is the way that I'm gonna store the information for each series for the block of the hand is gonna depend because of the way that structs work. I have to think about when I'm gonna initialize each thing. That's what makes it difficult. Because otherwise, I think I could just filter first and then store all the information somewhere in a vector or something like that, and then think about the relationship between them. But I think I have to think about it simultaneously because the filtering process is directly correlated with the structure of information. That's what makes this more difficult, I think. Because I can't just get all the actions and then think about how I'm going to split the actions so I have the correct relationship. I have to think about as I go through the actions how I'm gonna associate each action with a line for each player and each street. I think what I can do is put this here, and then I can also copy. There's gonna be at most 4 streets. Just pre-flop, flop, turn, and river. So this is fixed. Actually not fixed because obviously if everyone folds or the hand finishes before, then it's gonna vary, but let me think. Yeah, maybe this is a good way to put it because then I can make the players put this like make arrows like this. Oh, but then let me think. That's the difficult thing here is how because there's gonna be a flow here. There's gonna be actions, and then depending on those actions, is they're gonna go back, and depending on whether or not they folded, there's gonna be an arrow here, a connection or not. But the flow is like this: arrow here, then here, and then here, and then again. And the actions are the bridge between the rounds and the players. Just out of example. Oh, it can't be actually. Let's say something like this. Yeah, I think that probably works. So what I'm trying to figure out here is because maybe can I change the color here of each one? I guess just press this. What I'm trying to figure out is the color here. Because the thing that matters is the flow. The thing that is gonna give me the line is this flow of information here. From the player to the action to the street. And vice versa. And each player maps through a set of actions, I think. And leave that. I think it's kind of confusing. Let me see if I can think about it. So the question is, how do I find the line for each player based on these connections here? And I have to think about that it's going to be sequentially, the way that it's going to filter. It's going to start by the players because of the pattern here. It starts by the players, then it goes through the cards on the first round, round 0. So it starts by the players, then goes through pre-flop, and then I get the position of the big blind, small blind on this street here. Pre-flop. Turn. River. Yeah, so the first thing that I'm gonna have access is the name of the players. Name of the players. And the stack size of each one. Which is not that relevant for the actions. It's more for the analysis later. So then I'm gonna have access to the pre-flop. Actually, there is one round before the pre-flop, which is when you post the small blind and big blind. So the first thing that I'm gonna have access is who is the small blind and big blind. Then on the pre-flop, I'm gonna be able to know all the positions for each player. As it goes through... Yeah, so as it goes through the pre-flop, then I initialize both the position and the action for each one. But then that's the tricky part, because depending on how many actions, it's gonna be different. The line is gonna be different. That's what I'm trying to think. Yeah, so obviously what I can do is limit I can reset the action count, let's say, based on the street. And that's gonna allow me to map the line based on that. Because then, regardless of how many actions there is on each street, I can keep track of the sequence of the player, which player did which bet and which sequence. And what makes more difficult is that I have to think about it in Rust, in how to do it with the structs. So the position is a struct, players are structs as well. And the question is, what are actions? How can I create the actions? Is it gonna be multiple vectors, and then each vector is associated with a street and the player. How do I make the street and the player share the action? That's the question. Because that's gonna allow me to have the whole line at the end for each player. Yeah, I guess I can initialize a vector outside. So I make a vector of actions for each one. So this is gonna be the vector that works as the bridge between the players and the streets. Because I need to get this from this sequentially here. I place the logics of if-else statements associating the yeah, so I think this way probably works because each player is a struct that has a vector with actions. Then I make the if because I initialize the player. As I initialize the player, I put the action as well. Because when I initialize the position for the player, I'm gonna have the action as well. I think it works. So as I initialize the player, I put the first bet into the vector. Yeah, but then that's the thing, because then if I did it like this, I would have to create one instance of each player for each street. Because it's gonna make it easier to capture all the... So instead, what I can do is... So maybe it's better to leave the action outside of the player struct. The tricky thing is that I have to initialize the player with a value, I think. Because ideally, I have two different vectors. One vector keeps track of each action on each street. And then after the street is over, after the round is over, then I put the bets for that round, kind of like a map, an object with the street and the bets, I think, for each player. So inside of the player, there's the preflop and then the vector of the actions of... Yeah, but then, because if I do it like that, it's also going to be really hard to unpack the line based on the actions. Because then I'm not going to have any information about the sequence if I just do the vector thing. That's the biggest part, because if I store it as a vector inside of each player, then later on, when I get the line, I'm not going to be able to know what action came first to determine what was the line for each player. So I need to retain the information of the sequence of actions. And I think the only way to do that is with an object, probably. Because I mean, maybe with the vector and I use the index, but it feels more difficult for me. I don't think that creating all possible sets of actions is a good way to think about like creating all possible lines, check raise, check, bet, etc. I don't think that's a good approach. It just seems too weak, I think, because then you might not take into account different lines that can show up. It's probably better to create something that doesn't rely on that. And the thing is, I need to capture this connection between players. Where player 1 does an action, then from that action, player 2 acts. So that way is a lot easier to keep track of the line. Maybe it is easier to create the structs with the actions instead. I create a struct of action, and then the struct of action contain player and the sequence. It contains a vector of players. Yeah, but then it gets really confusing as well, because then each player inside of the vector would have to have a value which would be the amount of the bet. Yeah, but I'm thinking that the most important thing here that I have to capture is the line and the line, the bet sizes, and the positions. The rest, I think, it doesn't matter. And obviously the hero, which is me. But the problem is that I have to store information sequentially from the beginning. It's probably better to create the structs with the streets, and then I start on each street the actions sequentially, and then I think about after I go over the whole hand, then I capture the each action again. Maybe actually it's not that hard actually. I might be overcomplicating this, because I can just create a struct with the action, and then the struct is gonna have a value which is the amount that the action is, and then I create a new action for each action, obviously, and then I associate that for each street. But yeah, but then because then the streets would be just one value here instead of four, because I initialize each time. Or maybe I can count, put round here. And then I have to think about how I'm gonna name this. Maybe street. So as it goes, so the first thing that I get is the player. I'll create 6 different players. But then, let me think. Yeah, because it would be better if I put the action type here. That's the thing. Be a vector of actions. Because I need to capture the sequence of actions for each player. I think the relation between the position and the player is correct. Because, yeah, but then the thing that I'm also not sure is if I need to initialize first. Maybe it's incorrect. Maybe I should have position here. Yeah, that's probably better, actually, now that I think about it. And then I just remove this. Because each player is going to have a position. Yeah, that's a lot better. So as I create the player, I create the position. And oh, then I don't need the name actually. Oh, the name actually I need, because I need to see which one is going to be me. I could put a boolean as well, but I think that gets more confusing. So 1 if it's me and then 0 if it's not, but I think putting the name is probably easier to think about in the end, probably. But maybe it's gonna be easier actually if I put as a boolean to filter, since the name of the other ones don't matter that much, just the position. So I think I'm gonna do that actually. So I'm gonna initialize the player, and then the question is, what is the action? Should I put a vector there or the struct? I think it has to be a struct, and the struct has to have the value of the action and the street. So you need to have the value, the street, or the round, or and what else? And the sequence, but how I'm gonna capture that? Because let's say that I bet, they raise, and I re-raise, for example. Then I would have 2 different bets, 2 different actions for the same round. So I need a way to figure out which one came first. So I know the sequence, and I need to figure out a way to connect my actions and other players' actions with each other. So if I bet, then I keep track of that, and I keep track of the sequence basically, while at the same time breaking down based on street. But I think something like this is probably on the right direction. Maybe I put a ID here. Yeah, ID. And then I put I8 or U8 and sign integer. This can be... I don't think I can have negative bets here. I'm not sure if I lose, if there is negative amounts if you lose or something like that. Probably not. Yeah, I don't think there is. I'm gonna put it as U32. So ID is the number of the action here. I think that works actually. So every action I create this. For every action here I create this struct. It's gonna have the value which is the sum. Maybe we should put here sum which streets. Uh, yeah, I think this works actually. I think I found a way. So as I create the player, I create the action, which is gonna have the value, the round, and the ID. And then the action is gonna contain. So I need to create the action first, which is gonna contain the round, the value, and the ID. And then I make the player based on the action. I think that works. Yeah, so the round first, then the action, then the player. Yeah, but then how I'm gonna update, because that's the thing. Ideally, I only create each one once, and then I just append to a vector or something each time on the future actions. Or action, I think I can create any one each time. That makes sense to me. But I don't want to create a new player for each round and each different action again. I think that's just repeating yourself. So it will be better if I find a way to just use the same. Oh, okay, I think I can just do vac here of actions, obviously. So each player has a vector of actions. Yeah, that makes sense. And then I append the actions. And then that way the actions work as a bridge between the street and the player. And then later on I can use the ID to get the line. I think that works, yeah. Unless I'm missing something. And so now let me think about how I'm gonna filter this stuff here. Obviously, I expect that I'm gonna get a lot of bugs and I'm gonna have to rethink this, but I think, at least for now, it seems like it makes sense the way that I'm doing. And I have to search how to initialize a struct with a vector in Rust. Or in Python, obviously, it would be a lot easier, I think, to build this. But that's why it's good to do it in Rust, because I learned more. I think I'll be right back. one thing that I almost forgot is to put the hand here for each one. Which I guess is gonna be a string as well. Maybe actually I create a struct with all the hands and because I need to create maybe the other thing that I'm thinking about is it's probably better to create a hash map instead of creating structs like this. But maybe it's unnecessary. But for the hands, I think it's better to have a hash map. Or I can do the logic later. I think both ways work. It's just which way is gonna be easier to think about. Because I can either make this a string slice here, and then I just pass the value. Let me see. For example, pass S2 here for the hand. Or I can create a map or a hash map with all the hands and what they mean. So as for spades and then the hand, and then I can put that value here. But I think it's easier to just make the hand equals to a string slice. And then I think about how I'm gonna create the strength of the hand later. I'm getting this string slice and then combining with the flop or the board to get the hand strength of each player. The other thing that I can do that I just thought about is that in PySolver, if you create a simulation to the river, it takes a lot less space. So usually what I used to do was you select a flop here and then you create the whole simulation. And then what the solver does is solves the game for the flop, turn, and river. And that's usually the way you do it when you're going to study, because obviously you want to study a bunch of different lines and different bet sizes for each one. But what I can do here is actually solve for a specific flop, for a specific board that was in the game, and this reduces the size of the game tree a lot, which allows you to, it also makes the simulation faster, which allows you to put more bet sizes and also run more simulations. So I think this might be actually better for what I'm trying to do, because I'm gonna have the bet sizes for each thing, and I'm interested in what actually happened in the data set. I'm not gonna go over simulations that were not part of the data set. The whole point, I don't think I'm even gonna go over the simulations manually. The whole point is just to get the percentages of how much my opponents are betting and which streets they're betting and how much I'm betting, and compare that with the solution from PySolver, and then load the lock as well. Yeah, so after I have the bet sizes, then I can get the frequencies based on the data set, and then I can contrast the frequencies, the actual frequencies from the data with the frequencies from Pio, and then I can node lock based on the difference. Which might be really hard, but I think it's gonna be really fun actually to do. Because it's so practical for me. It's kind of fun to build it. Now I'm thinking about whether or not I need to have the game before I create the file, but I don't think I need to have the game. I think I can create the game on this file here when it's time to make the bridge. I think I'm gonna change the name of this file as well. The thing is, I don't want to make the same name. Let me just put bio here. And then I put bridge here instead of bio bridge. Yeah, I don't think that having the whole game is relevant to capturing the data, because it's probably better to do it. Because I don't need the strength of the hands, I just need to format the data to use it on this one later. So I think what I'm gonna work on now is to create the filter. So how to iterate through a buffer. Yeah, the thing that is gonna be difficult is lifetimes as well. I'll focus on the patterns first. I think I'm gonna practice some touch typing, and then I'll continue this after that.
Let's get down to business.
I know that this is really the information, but I don't think I can iterate over this. That's the thing. Or maybe I can iterate through the string actually. Because this is putting the content on the string. weight over a character is gonna be harder to filter based on the patterns. But I'm gonna have to create a vector and then make some condition based on the vector for the patterns I want to show. To mark the start and the end of the pattern.
How can I be sorry if I don't know the crime? I should be mad cause you never told me why. Still, I can't seem to say goodbye. Ooh, when I try to fall back, I fall back to you. When I talk to my friends, I talk about you. When the Hennessy's strong, all I see is you, is you, is you.
I'm actually finishing this one. Let's see if it works. It's like this. It's obviously gonna have the same lifetime for all of them. Maybe not. Or maybe not actually. Because the player probably has a longer lifetime than the round. Actually not, because it's connected through the action, so I should have the same lifetime. It's just easier to the same lifetime. Let's see if there's... I changed the name, so... But the wrong thing there. So I think I need to put the lifetime here, because I have the round, so it's pretty much the same thing. But now I'm not sure if I should do like this. tried to disabilitate these warnings here, but it didn't work. From what I found, you're supposed to do this, but at the beginning of the file, and I try at the beginning of the file, but it doesn't work. It's kind of annoying. It just clouds the space here. I forgot to decrease the volume of the thing. Oh, it needs to have the... and it goes after. Again. Let's search again how to disable. I think the easiest way is just to comment this stuff out, but it would be nice to... eventually probably I'm gonna look into how to disable the warnings, just so I don't have to comment and uncomment every time. Okay, only one warning. Where is this coming from? Read file. Oh, here. I guess it's because of the stuff that I commented somewhere, but maybe not. You know, probably I was using it before to get the path to the file, but because I'm using this, then I stopped using the path here. But I think I'm gonna leave it there. Oh, this here. Oh, it's because I comment the stuff out. So hopefully now, source, read files, line 18. So do I have to put on the... I guess I have to put on everything. The lifetime. But it's weird that here I don't have to. Maybe I do. Let's try again. Okay. Also weird that it's giving me this mistake now, and it wasn't doing that before. And it doesn't make sense for me to be this import here. So I don't know what's going on. I'm gonna try one more time and then I'll just import the recommendation there. If it doesn't work. Looks like OBS is crashing. Okay, so it worked. Nice. But it's breaking my computer. It's lagging. Not lagging, but it's... don't know how to say it. Yeah, but now I'm looking into characters. So, I think I'm gonna see if there's a way to go over words. But maybe character is enough. Because the thing that I'm thinking about is if for every character I append to a vector until I have a word, it gets really complicated. Maybe I'm gonna have to use regex, so. Or maybe I can just type the word on the regex and it works. Yeah, but then the problem is if I get the regex, then oh, actually I can probably use filter instead of mapping through. And filter the whole string instead of going by character, and then I can use the regex. It's probably better. I don't know what this means here. But I guess when you raise and make it like this. Okay, so it looks like a... Okay, so this is probably a flag for reading this stuff. And these are probably the patterns. One player. Yeah, I can map through this string, I think. What's this? I think I understand. So first he filters, then he creates a vector with all the matches based on the filter of the input string. Then he matches he gets the vector and filters based on the patterns that were captured here. And to me, I think it's gonna be different because what I wanna do is put logic after, so I think I'm just gonna map, and then instead of doing these captures here, I'm gonna do the logic of what I wanna do. So I'm gonna have multiple different nested filters, nested mappings. No, but I wonder if I can do that. Because I don't think... I guess I can because... No, but the map is gonna be each character of the main string, so... I don't think inside of here I can map over the substring, if that makes sense.
When you're tired, when you're lonely, can just reach out and on. No, I'll be there. I'll help you weather the storm. Us together, nothing's ever felt more like home. No, I'll be there. You will never be alone.
Maybe I'll leave the other one open because it's probably gonna be helpful. This one. I think I'm just gonna copy this stuff and then I'll think about how I'm gonna change this. Instead of looping through the thing. I wonder if I can print this.
In that moment when you're feeling like there's nothing at all,
Reach out to me, know that I'll answer the call. All I need is your love tonight. All I need is your love tonight. All I need is your love tonight. All I need is your love tonight.
And the thing about doing matches and then for each match I create the... I guess I can do that because I can put a whole function inside of the match actually. But then the problem is that I would have to... Inside of here I would have to create another map. It doesn't... I don't think it works. Because what I want is to get both the beginning and the end. So separate as if it was a block. And then based on that I... Actually, now that I think about it, I have the... let me see. I have the Italian project that I did, which is pretty similar to this. So I think I'm gonna open the project. Because it's the same structure from HTML page. And the Italian project I filtered the HTML, which is just some code that I found from someone else. So I think I'm gonna see how I did there, and see if I can copy or do something similar. I think it was on this one. Yeah, so it was document, unwrap, and then find. Yeah, but I wonder if this is gonna work for... Maybe it does actually. Yeah, I think it should work. Unless I can't create a custom name though. In which case I've tried something different, but this seems a lot easier to do. Instead of putting the... But the thing is, I'm not sure what is the structure of this thing. It's probably a struct or something like that, so it might not be possible because these methods only exist for this type of... which is a document type. From read cursor. Oh, but I can do the same thing actually. Because I can just put the string here. And put my file instead of... It's actually the same thing pretty much. So I'm gonna use this as well, probably. I think I'm gonna practice touch typing now. I've been saying this for a long time. Just put some music that I never heard of, so... or some mix that I never heard. Not sure how long I'm gonna continue doing this. I'm probably have been here for hours, so I might stop soon. But I think that's gonna be the way that I'm gonna do. I'm gonna try to do the same thing that I did on the other project because it seems really simple. Then instead of putting this is gonna be the pattern that I'm gonna use to find instead of putting TD, I put players or whatever it is there. And then I put the logic here for each one. And then once I have all the data, I write the data to a file, and then after that I think it's gonna be a lot easier because it's just figuring out. Maybe it's gonna be hard because I don't know how hard it's gonna be to connect with Pile, but I don't think it should be that hard. You just use the system, learn how to use Rust to communicate with the terminal, and then start processes and learn the Python commands, the Pile commands for Python, to build the nodes, and then after that I think it's pretty easy. Pretty slow still. I think my record is 150 or something like that in 15 seconds, which is good but not that good. I actually think I suck at this. I'm gonna try to get to 200, but I think it might be too difficult. I think probably from 180 up is genetics, but maybe not actually. Maybe you can do it just with hard work, but it feels like there is a cap, there is a limit where some people can't write faster than that, or type faster than that. Fuck. Whenever I try to go really fast, I ended up going too slow because I miss a lot. And usually when I'm just focusing on getting the right words or typing correctly and not rushing, then I go faster. Yeah, it's absolutely insane. 145. 200 is extremely difficult. Yeah, sometimes the hero is doing pretty well. But then the issue is that I start thinking about it because I don't want to miss, and then becomes slow again because I make mistakes. But this was pretty good actually. First part here. So if I just focus on the words, the problem is if you miss, you lose momentum, and then damn. I think I'm really close to beating my record. These mistakes fuck me up. Just need to focus on getting it right instead of trying to go fast. Also, reading the words in advance helps as well. But then the problem is if you get one wrong, then you get a bunch of them wrong. Because they're counting on the fact that you're gonna get the word correctly. What makes it more difficult as well is that I memorized how long does it take. So usually the last line, I need to get it, I need to finish the last line to get close to my record. So when I see the time running out and I'm still in the middle, that's when I make a lot of mistakes because I know I have to go a lot faster to get there. But if I just focus on writing correctly, then it becomes more likely that I'll write faster.
Let me down easy. For your love for me is gone. Let me down easy. Since you feel
Fuck.
to stay here alone. I know it's all over. But the last goodbye. Oh, let me down easy. Let me down easy. Let me down easy. Let me down easy. Let me down easy.
Yeah, right here. Right there is where it fucks up. Because I know that I need to go faster if I wanna beat the record. Pretty sure that up to 160 I can get someday because I'm really close, but beyond that I don't even know how they do it. Seems impossible. It's one thing to reach there for 1 second. It's another thing to write at that speed for a long time. It's just insanely fast.
When you pass by me, say hello once in a while. When you pass by me, baby, doesn't it hurt so much to smile? We
Close.
promise that we'd still be friends till the very end. Begging you, baby, let me down easy.
Fuck. I think I'm gonna focus on accuracy a little bit, just so I forget about trying to reach the time. Because I'm making too many mistakes. Yeah. Fuck. Almost.
Let me down easy. For your love for me is gone. Let me down easy. Since you feel to stay here alone. I know it's all over. But the last goodbye. Oh, let me down easy. Let me down easy. Let me down easy. Let me
Oh fuck. I knew I was close, then I fucked it up there. At the end. Yeah, I was almost so close. My record is 149 from 50. I did a shit ton of tasks already. 17,000 tasks. So definitely not talented for this. Yeah, 150 is the record. Very close. I just have to focus more on the words and stop thinking so much. And that's when I go fastest. This C is fucking me up as well. Because sometimes I do it with one finger, sometimes I do it with the other one. Because of the words. And sometimes I do it with this finger, and then sometimes I do it with the other. The chart says to do it with the middle finger. Just gonna copy this stuff here so I don't forget. I think I'm gonna erase this. And then obviously the pattern inside of here is gonna be different.
I see you standing at the front of the land, waiting for something I can't make out, but I wanna talk to you to pull you aside. I wanna ask you to come with me.
Yeah, I'll look at this later. I think for today I'm just gonna try to beat my record for a little bit, and then I'll stop here, and then I'll continue to do this another time. Fuck. Oh, I was gonna see the charts, actually.
There's no place I'd rather be.
Yeah, so it says to use the middle finger for the C, but for some words it's kind of weird. It's not really good because I feel like my index finger has to go to the F or the R or something like that. And then it becomes a little bit awkward, so I'm trying to figure out which is the best way to do it.
You run your fingers through the palm of my hand, pulling me closer, drawn by your commands. Like I've seen you, like I've known you before. An intuition that this is where I belong. Standing with you in my arms.
Fuck. feel like I need to slow down a little bit. I try to go for accuracy instead of speed.
And when the lights come down, I wanna feel you stand.
If I go really slow, that's the speed that can go.
Can you hear me out?
Fuck.
There's a lifetime in front of me. And when my time runs out, I wanna feel you standing next to me. Baby, I knew this time would arrive. I knew this time would come. Ever since
Oh, I choked there at the end.
I said you're
I'm still behind, but close.
oh my God. Tell me I'm wrong. Oh my God, oh my God. I wanna feel you standing. Late in the evening when the sun comes down, under the starlight as the birds fly by, I see the dust fill the twilight skies. I feel the warmth of your
It's so annoying because I know I'm so close, but I just can't go faster. If I try to go faster, I start messing everything up.
It's in the air we breathe. This all around us now. And when the lights come down, I wanna feel you standing next to me. Can you hear me out? There's a lifetime in front of me. And when my time runs out, I wanna feel you standing next to me.
Just stop focusing on the time there. It's messing me up at the end. Also trying to rush. It's really difficult, not sure. Fuck. I'm just gonna try to not go fast and just get everything right and stuff.
So what are we waiting for?
Someday we'll get it. I need to stop restarting every time I make a mistake, because then I train myself to do the wrong patterns, and it just gets worse and worse. It's like everything else, the more you focus on the results, the worse you do. And the more you focus on the action itself, the better you do. That's why it's also good to do this. It helps you train your awareness over if you're focusing too much on the future. I fucked it up in the end. It was really fast there, in the middle. And stop to restart every time.
Drive up the coastline, stop by the shore,
Yeah, it's too many mistakes that I'm making.
stare at the ocean, wait for a call from the ocean to lead me away, lead me away.
I think I'm gonna stop here. Very tired. Next time I'm probably gonna continue. If I think I might do this, continue to do this off stream a little bit. Not really sure. Next time, what I'm probably gonna do is the stuff that I was talking about, where I'm gonna put the regex inside of this thing here, and then for each block, for each pattern, I'm gonna extract the information, and I'm gonna put the structured information in a file in the way that I was talking about there, with the graph and the relationship between these things there. After I have that, I'm gonna use this information to build the spiral simulations, and then after I build the simulations, I will node lock the simulations and hopefully extract the percentages of which portions of the game tree I need to bet or fold more or do whatever in relationship to the way that the solver would play against the opponents that I'm playing. So yeah, maybe I'll also do this stuff next time instead of working on this. So I will see. I'm particularly interested on this one, so I might do this one as well next time. And I'm probably not gonna stream for a long time because I'm working on other projects, Web3 projects simultaneously as I work on this one on stream. I'm working on other stuff off stream, so yeah, see you until